Okay, I'm slowly gathering the speakers.
Let's see, this is the button for the reactions. What are the reactions? We have superb, laugh, celebrate, thumbs up, heart, claps, and the trophy. Oof. Oh no, it's code beam all over again. I have no doubt that it's you, Pablo. Okay, so apparently there will be some longer lasting issues with live streaming. So good for everyone that is actually here. It's okay yes, it will be possibly repaired after the first break. There must be not mixing up my channels. So I don't need this, and I can postpone my tweet with the live stream link. It will come up later. Let's see if we cost this, we'll get to talk to the world. And we are at the exact hour wherever most of us are. Let's say not what kind of hour. So shall we get on, Annette?
Let's get started.
Perfect. All right, everyone. Welcome to this 20th ACM SIGPlan International Workshop on Erlang. I am Stavros Aronis, and together with Annette Pinusa, we are the co-chairs of this instance. While waiting for the session to start, each of us had a crash on their network equipment while the other was online. So the system with redundancy to machines that we in Erlang are very familiar with actually does work. We also have the workshop organizers in us in the session. So even if both of us crash, there is a third party, as should be the case. So hopefully things will work fine from now on. I have prepared a short welcoming talk just to get everybody settled in and relaxed and ready. And I will get on with it. So this is the 20th +1 years of the Erlang workshop. The first instance was back in 2001, but at that point it was not yet under the umbrella of ACM. 2002, first ACM SIGPlan Erlang workshop. Many of you have been in the community for a long time. Many of you are recognizing faces in such an old photo. I haven't studied a lot of the history of the workshop, but please do share your stories during the breaks and in other occasions that you will get today. And here we are, 20 years later, 2021, in the 20th instance of the ACM SIGPlan Erlang workshop. And what an occasion this has been. So the workshop has been going on for a long time. I actually had my first presentation here as my first academic conference presentation back in 2011, where there was a peak in the number of papers presented. That was in Tokyo. Kenji might remember that I was late for my session and he had to reschedule me at the end. So great way to start my PhD, let's say, life. Yeah, Workshop has had always a lot of great work submitted, enough good work presented and accepted. We are a little bit scared in the organization side because numbers as of late are getting low. There's a lot of great work there that people are talking about in a lot of other venues. A lot of it is very, very much suitable for the workshop. So I know that all of you have friends out there that are doing great things. Like getting them to write for us as well is great. Really encourage you to do so. We are trying to do this ourselves with varying degrees of success, as you can see in the program. Yeah, since this is this kind of like anniversary of the workshop of 20 round years, we went back and did a bit of, we were trying to figure out some way of celebrating and organizing something. And the easiest thing that we could check was people who have published a lot. And here you can see our most prolific authors. A lot of them are already in the audience today. A lot of you know a lot of them. Over the years, we have had more than 230 authors presenting more than 180 papers here, so a lot of great work. It just so happened I was not intentionally looking for this kind of motivation that Kostis happened to be on the top, but he only has 19 papers presented in the workshop and not 20. So we had to invite him to give a keynote to round up the number. So he will be giving us a keynote later on. This year, we had a lot of people in the program committee, and you will see all of them in the next slide. We had 9 papers submitted by the deadline, which was not extended this time for the first time. We hope to continue on this trend in later years, so keep that in mind in your academic planning. Out of those 9 papers, 6 papers were accepted in this occasion, and all the papers got great feedback, so we are hoping that we will see the remaining ones in future occasions or in other places. We went ahead this year also and invited lightning talks to be submitted and presented, just to have a wider audience participation and more occasions, especially since we have a virtual event, for people to show what they are doing in a like very central and very on the stage way. And the other thing that we managed to organize was some scholarships. We know that ICFP had gone out of their way to make it to make the fees and attendance registration easy for everyone, no matter what. But we could also, for those that could not afford even that, we could cover the small registration fee with the help of our sponsors. And we actually have some attendance in ICFP and the Erlang workshop, hopefully, that have been receiving this scholarship. Here are the people of the program committee who spend a lot of time writing reviews and reading papers carefully and giving, we hope, helpful feedback to all the people who are presenting their publications today. Europe is heavily represented. We tried again to go out of our way and find more people. Some accepted, some did not. We are aware that we should represent more all over the world, and we'll try again next year, hopefully with more success. Thank you very much to all of you who really spent the time and wrote thoughtful reviews and helped people improve their work and before they present today. We should also thank the organizers of ICFP, starting with the general chair, the industrial relations co-chairs who helped us with the sponsorships, the workshop co-chairs that helped us with organizing everything from the call to this website and all of that. And especially the student volunteers who are running around these days and are taking care of everything and making your experience as pleasant as possible, and definitely deserve to get most of the hearts because they are the ones that are actually around here today and among us. The other ones are also academics already, so like they have enough praise. Students are now starting, so the more you love them, the more they go ahead. We can take the opportunity to especially thank the sponsors that come from our community, since they are also funding the scholarships. The Erlang Ecosystem Foundation, sponsoring ICFP and the Erlang Workshop and the scholarships, and so does Erlang Solutions. Again, it's great to see our little community industrially represented among everybody else that is on the front page of ICFP. We are really happy to get them there, and we are really happy that they are with us. A few lines about today's schedule. As you might have seen on the website, we have 4 sessions of presentations. This is the first session where I'm welcoming you, and we will present. There will be 2 paper presentations as well. Then we have breaks. All the breaks will take place in Ermit's Lounge, and they are coordinated so that all conferences have breaks at the same time. So if you have friends that are attending, you can go there, talk with them, and drag them in accidentally afterwards, or let them drag you somewhere else if you don't care about much. Then we have the keynote on the second session so that more people all over the world can more easily access it. And then we have session 2 and 3, again with 2 papers presented. In all of these sessions, we have also added lightning talks so that attendants will get to talk about what they have been doing early enough and get more discussions happening during the breaks. If you have not sent us a proposal for a lightning talk already, you can definitely rush and send us one more, because we have exactly 1 slot at the end. And of course, after the end of the workshop, you are very much welcome to hang out in the lounge. A lot of us will be hanging out. It will be late enough. You can talk about work. You can laugh. Interesting things happen in the Erlang community after long days of conferences. Finally, some info about Ermit itself. If you are presenting, if you are on stage and having your camera on is nice. As far as I can see, Ermit does not allow the audience to show their faces during all the time, but I see a lot of reactions during the talks, and these are great, at least for me. I hope for the speakers as well. You can always go to the lounge. You can take a break yourselves and go to the lounge, and there you can establish a hallway track or do whatever you want, and you can enter the sessions again whenever. All the features of Ermit are available in the workshop, so you can raise your hand and be invited on the stage. You can write your chat messages, Q&A feature where you post questions. You can even initiate polls. I think if you're on the stage, we will try to keep an eye on all these things. Remember to be welcoming, inclusive, and respectful. I'm sure that you don't need a reminder for this. If you face any issues with Ermit, you can go to the help desk in the lounge. And remember to never, ever use multiple Ermit tabs, or the universe will collapse. With that, I wish you all to enjoy the Erlang workshop. And I want to especially thank Annette, who has been helping me. We have been trying to set up everything nicely for this one single day over the last 9 months.
And I could not have done it without Stavros, of course. So thanks for the introductory words. And with this, we start with our very first talk of today. which will be about a general purpose implementation of Raft in Elixir named Graft. The presenter is Matthew L. Naroon, and yeah, with this you can start sharing your slides. I hope this works. Perfect. Thank you very much. And off you
go. Can you see my slides?
Yes.
Okay, nice. So, hi everyone. I am Matthew. Today I'll be presenting Graft, General Purpose Raft Consensus in Elixir. So this presentation has an accompanying paper worked on by myself, Duncan Paul Attard, and Adrian Francalanza. Our tool, Graft, is open source and available both on GitHub and the Hex Package Manager. So the presentation will be split as such. I will start off by going over consensus and fault tolerance. And from this, I will lean into the Raft consensus algorithm. Then I will discuss our tool, Graft, and how it uses the Raft algorithm to allow developers to build fault-tolerant and distributed applications in Elixir. I'll complement this with an example where we will build a fault-tolerant and distributed key-value store to act as a very simple database. And finally, I'll talk about some of the verification techniques we use to support Graft's correctness. So let's get into it. Consensus. So consensus is used to provide fault tolerance within distributed settings. So what fault tolerance means is, as I'm sure a lot of us in the Erlang community are familiar with, is that an application can still reach its expected output in spite of failures occurring during its runtime. Now, what consensus algorithms do is they provide a degree of redundancy by replicating one machine's actions across multiple machines to provide a degree of fault tolerance. So it's important to note that there is always an upper bound in the amount of failures that can occur without consequence. This upper bound would always depend on the algorithm in use and the assumptions it makes. An example of a consensus algorithm is Paxos. Now, this is probably one of the most infamous examples that I can give based on how difficult and hard to implement in practice the algorithm is. In fact, a lot of research has gone into making the algorithm both easier to understand and implement correctly in practice. However, a lot of this research has gone with minimal successful results. And this is what motivated Raft, the consensus algorithm designed to be understandable. Raft provides fault tolerance up to F failures for a cluster of 2F plus 1 nodes, all whilst assuming the fail-stop model. This means that as long as a simple majority of nodes in a Raft cluster are live, then we can expect our application to behave as expected and provide our expected outputs. At assuming a fail-stop model means that Raft equates failures to node crashes. So if a failure were to occur, we can assume that the node on which the failure occurred crashes immediately. Raft uses the replicated state machine approach, which means that nodes in the Raft cluster can be seen as if they are state machines that have their own start state and transition to other states based on commands that are sent to the machines. What Raft does is that it keeps track of the total history of all commands sent to these machines in an ordered list. This list is known as the replicated log. The log is kept consistent across all nodes in the consensus cluster. Now, Raft achieves its levels of understandability using two main techniques. The first technique is the use of a strong leader. What this means is that there is one and only one node at a given time which governs the rest of the consensus cluster by taking most of the main decisions for the operations that should be carried out. This centralizes a lot of the operations, making it easier to reason about. The second technique is that Raft can be decomposed into two sub-problems. the leader election and log replication protocols, which I will be giving a short demonstration of in the coming slides. For these demonstrations, keep in mind that a node in a Raft cluster can be in one of 3 states at any given time, these being the follower, candidate, or leader states. Now, leaders, as I mentioned before, govern the consensus cluster. Candidates are nodes that are trying to become a leader, and followers are passive members. They only reply to messages when sent to them. So let's now take a look at the leader election protocol. So Raft initializes all of its nodes as followers, as the passive members, but it also initializes them with timeouts. These timeouts are used by the nodes to notice that no leader is currently active in the consensus cluster. Note in this case, the topmost node in our cluster will be the first to time out and the first to realize, wait a second, no leader is currently active in my cluster. So once the node times out, it will promote itself to candidate, starting an election. Once the election is started, the candidate will send vote requests to all other nodes in the cluster. Once received by the followers, their timeouts refresh in order to prevent unnecessary elections, and the nodes will decide whether to grant or reject the vote to that candidate. In this case, the followers will send an acknowledgement granting the vote to the candidate. Once the candidate receives a majority, a simple majority of votes, it promotes itself to leader, winning the election. Hooray. As you may see, the other nodes, however, have not stopped their timeouts. This is to cater for the case where a leader dies. In that situation, the other nodes will once again time out and restart a new election. However, since we have a leader up and running, to prevent the unnecessary new elections, this leader sends out heartbeat messages periodically and indefinitely in order to restart the followers' timeouts. Acknowledgements are always sent back to say everything's okay. So that's the leader election protocol. Now let's take a look at the log replication. The goal of this protocol is to accept client requests, replicate the request on all the logs in the consensus cluster, execute the request, and return a return value back to the client. So let's see this in action. It starts off from the client, as the client sends a request to the leader with a command C to be executed on the state machines. Once the command is received by the leader, it will append it to its local log without executing it. It then sends append entries messages to all other nodes in the cluster, letting them know that a new command has been received and it should be appended to everyone's local log. And so the followers append the command. They reply back to the leader with an acknowledgement, letting the leader know, hey, I've correctly appended my command to my log. Once the leader receives a simple majority of these acknowledgements, it realizes that it is the command has now been appended to a majority of the logs and says, okay, it's safe for me to execute the command. And that's what it does, yielding its return value. This return value is then sent back to the client as a response to the client request, ending the log replication protocol. I will now move on to Graft, our tool which uses the Raft algorithm in order to allow developers to build fault-tolerant and distributed applications in Elixir. Our tool is split into 3 components: an API, a behavior, and configuration. I'll discuss each of these separately in order to explain how Graft functions, and later we'll have a look at an example. Let's start from the API. So Graft exposes a minimal API. The first function, graph.start, takes no arguments and simply starts the Raft protocol on our configured cluster. The second, graph.request, takes two parameters. The first is the identity of the server to which the request should be sent. The second parameter is the command that should be executed on the state machine. Graft also exposes a behavior. This behavior should be used to define how client requests are handled in our replicated state machine. Note, it may look and feel a little similar to the behaviors used through the gen server or gen state machine functionalities. So this behavior exposes two callbacks. The first callback, init, which takes one parameter, which is a list of arguments. This init callback should initialize the starting state of our replicated state machine. The second callback, handle entry, takes two parameters. The first is the command that should pattern match to the client request made through our graph.request API function. And the second captures the current state of the machine. This callback should return a tuple containing both the response for the client and the newly updated state. Lastly, Graft uses Elixir's config module to configure its applications. The required keys are listed on screen. Firstly, a cluster should be specified as a list of nodes. Then the machine module is specified. This is the module that uses our graph.machine behavior. And along with this, the list of arguments sent to the init callback should also be listed. Finally, the configuration requires users to define the server and heartbeat timeouts used by the Raft algorithm. Okay, so now let's put these three components together to build an example, which in this case, we will build a distributed key value store to act as a simple database. Let's start from an API for our application. Inside a module called diskv, our distributed key value store, we'll define two functions. A start function will simply call graph.start, which in turn will start the Raft protocol on all nodes we define in our configuration. The second function, put, will take three parameters: a server to which a request will be sent, and our key and value, which we want to store in our KV store. What this function does is as such. It builds the command to be sent to our state machine. In this case, it's a three-tuple of the atom put, followed by our key and the value. And lastly, it simply calls graph.request with the server to which the command should be sent and the command we just built. That's it for our API. Now, in a separate module, we'll define the use of the graph.machine behavior. Notice we have to implement two callbacks, the init callback and the handle entry. Let's start from the init. This will take one parameter, which is an empty list of arguments, since we do not need any additional information to initialize our machine. This function simply returns a tuple with an OK and an empty map. This empty map will be the starting state of our machine. Our second function will be callback, will be the handle entry callback. This takes two parameters, the tuple with put, key, and value, and our current state S. This function will build a response for our client, which is an OK atom, and the new updated state for our machine. In this case, it will put inside of our state S our new key and value, and return both of these as a tuple. Note that our handle entry parameters of the three-tuple put k and v pattern matches exactly to the command sent in the client request. Finally, all that is left is to configure our application. This example will use 3 nodes defined in our cluster key. We'll have server 1, server 2, and server 3, located on S1, S2, and S3 on localhost. Then we indicate our machine located in the diskav.machine module, specify no arguments, and define a server and heartbeat timeout in milliseconds. Okay, now that we've built the code, let's jump into our interactive Elixir session and see how this works. Using the session for server 1 on S1 at localhost, let's start our application using diskav.start. This returns a list of 3 OKs, 1 OK for each Raft protocol successfully started on each of our nodes. Nice. Now we can go ahead and put something into our KV store using our diskav.put. We'll send the request to server 1 with the key Erlang and the value 2021. This returns OK. Notice that this OK matches exactly the response we defined in our behavior. OK, I've gone ahead and extended the example to include a fetch functionality so that we can see if our put request actually did insert the key and value into our store. Let's go ahead and use this kv.fetch, sending our request to server 1 with the key Erlang. This returns 2021, which is indeed the value we assigned to our key. Now, note that, recall that Raft provides fault tolerance up to F failures for a cluster of 2F plus 1 nodes. This means that as long as a simple majority of our nodes are running, then we should get expected outputs. Hence, since we have 3 nodes running, I can go ahead and crash this Elixir session for server 1, access the session for server 2, and send a client request using our diskav.fetch function. This also returns 2021, as since the majority of the nodes are operational, consensus is still conformed, and so expected outputs can be achieved. For the full example of diskav, I will address anyone interested to my GitHub. So what makes Graft unique is the post-deployment guarantees it provides through the use of runtime monitors. We allow developers to runtime verify their applications using our suite of monitors that we have defined using safety properties derived from invariance of the Raft algorithm. These monitors observe the execution trace of a system at runtime in order to determine whether the trace observed conforms or violates the properties that are specified. We use Detector, which is a tool for runtime monitoring systems in Erlang, in the Erlang ecosystem. And this small demonstration shows how Detector monitors work. So the monitor can be seen as 2 separate components, which are a tracer and a monitor. The tracer uses Erlang's inbuilt tracing functionalities in order to capture received and sent messages. So consider our node receives message 1. This is captured by the tracer and forwarded to the monitor. The monitor simply observes the message and checks whether it violates property P. If no violation occurs, it simply waits for the next event. Consider the node sending a second message. This is also picked up by the tracer, forwarded to the monitor, which is observed and checked against property P. Once again, no violation, the monitor waits for the next event. Finally, we'll consider a third message. This is sent to the monitor, observed, and the monitor checks the history of events 1, 2, and 3 against property P, notices that this violates the property and hence reports a violation. This then allows developers to check where the violation occurred and the exact history of events as observed by the node being monitored. This concludes my presentation. I would like to remind you that Graft has an accompanying paper, which I go into more detail about Raft and how we implemented it in Elixir. And we also go into a performance analysis of Graft, where we show the tool to be comparable in performance to other state-of-the-art implementations. Our tool is open source at this link. I thank you once again, and I will happily take your questions.
So thank you very much for the presentation, Matthew. So are there any questions? I'm having a look. So in the Q&A, I put a question in regarding this performance relation. So you did some performance comparisons, measurements, and Graph performed equally well, or is there any situation where you need to look out because there might be some issues, or because it performs superbly better than other implementations?
So we compared Graft against two other state-of-the-art implementations, one in C++, and the other one in Erlang, which is raw. So Graft performed equally well against both of them. So there were no significantly different results in terms of Graft being way better or way worse than any of these two state-of-the-art implementations. However, some of the design decisions taken in these implementations may motivate you to either choose Graft or choose raw instead, for example. These design decisions being, for example, in raw, instead of using timeouts, they opt for a monitor-based approach, where they use OTP monitors to check whether nodes are alive, instead of the timeout system that is used in the Raft algorithm. Now, the disadvantage that gives is a longer election process, since the randomness of timeouts may allow nodes to timeout exactly as a leader dies, which means a new leader can be elected quicker, whereas the monitor approach makes the election process longer, as shown in our results. However, it has a benefit of there are probably going to be fewer unnecessary elections. So it's more of a trade-off, and someone deciding between the two should make their decision based on the languages that the language they would rather work with, or what they're more comfortable working with, and also on the fact base the decision more on their network requirements, right? So if our network can handle these longer elections or these few unnecessary elections, then we can go for one or the other.
Mm-hmm. Thank you. There's another question by Erland. How did the call to graph.request know that the message should be passed to handle entry? So is handle entry part of the behavior that you define?
Okay, I just found the question. So let me just read it again. How did Graph know that the message should be passed? Okay. Yeah, so in the implementation of Graph, we have this graph.machine module, right? So whenever a command has to be executed, then the Graph module knows, okay, I will send this command to graph.machine module. Now, this graph.machine module in turn calls the callbacks defined through your custom implementation, and it knows where to find those through the configuration and your overriding of the graph.machine behavior. I hope that answers the question.
Okay, and then one final question. Let's see. Okay, so this works. Question by Laura. What is the validation of the tool? So there are a few tests in the repository, and you mentioned that there is also this live monitoring, so this runtime monitoring that is enabled and that is checking things. But are there other testing approaches or maybe even verification approaches employed for ensuring that the library works as expected?
So yes, so from the beginning we planned to have a two-pronged approach to the validation, to the verification of the system. This being a mix of test-driven development as well as the runtime verification, which can be used along with the tool. So the test suite that we wrote was somewhat inspired by other implementations, but also through the Raft paper written by Ongaro and Austerhout, where they describe the algorithm. They mention exactly like in this case, this should happen, in this case, this should happen. So that inspired a lot of the test cases that we wrote, following their paper and their list of edge cases, etc. Then after that, we also went ahead and used the runtime verification, since the test suite on its own, one, did not provide as much coverage as some would like. And I think the reason behind that is the fact that it is really difficult to get test cases that cover every single edge case for the algorithm. And it's difficult to know if you are covering all the edge cases anyway. So we use runtime verification as an added guarantee that you can use, keep your mind at ease after your system is deployed. As I said, we have a number of properties which we formally verified, and these so far have not yet produced any violations during our testing of the system.
That's encouraging. So thank you very much again, Matthew, for the presentation and answering the questions. You're showered in applause, which is very well deserved.
Thank you. Thank you very much.
And for kicking off the workshop with the first technical talk. And we continue now with a presentation on Machina, which is a new quick check state machine library. And we will start with the video, and Luis and his co-authors will then be available for questions. So let's see, starting the video takes a little bit of time, but
welcome to this talk. My name is Luis, and I am part of the Babel Research Group at the Universidad Politécnica de Madrid. In this talk, I am going to present you Machina, a new quick check state machine library. First, I will briefly introduce you to property-based testing. Afterwards, I will go through the evolution of property-based testing state machines, and the rest of the talk I will be focused on Machina and the features it brings to quick check state machines. So let's start. Testing is the most widely used technique to ensure quality of software. Usually, testing is performed using a technique called unit testing, a technique that consists on defining tests one by one. For instance, imagine that you want to test a simple function that computes the reverse of a list. Just for this very simple program, there are infinite possibilities, so we can conclude that unit testing is hard. But nothing to worry about, because QuickCheck comes to the rescue. QuickCheck is a property-based testing tool that completely changed the testing paradigm. QuickCheck brought a new philosophy to the testing sphere. Don't write tests, but generate them. A test in QuickCheck is called a property, and the execution of a property is divided in three phases. First, we need to generate the data necessary for the test execution. Then, we check that the generated data satisfies the property predicate. And finally, if the test fails, a shrinking strategy is executed to retrieve a minimal counterexample. Let's now take a look at a property on reverse lists. As everybody knows, when we apply the reverse function to a list twice, we get the original list. This can be translated as the following quick check property. This is not the best property to test a reverse function, since it also checks the identity function, but it will help us to illustrate how quick check works. This property will potentially generate an infinite amount of lists using the list generator. Each generated list will be checked against the property predicate. If the predicate is not satisfied by one of the outputs, quick check will shrink the data and return a smaller counterexample. So property-based testing is a very powerful tool to improve our tests. And this simple approach works perfectly with purely functional programs. Unfortunately, not all programs are purely functional. But don't worry, quick check has support for stateful programs. We just need to introduce a couple of concepts. So what do we mean by a stateful program? A stateful program is a kind of program in which the result of its execution depends on the previous interactions with the program. To illustrate how to test stateful programs, we will use a counter. This counter will have a very simple API. First of all, we need commands that permit us to start and stop the counter. We also need a way to modify the value of the counter. To modify the value of the counter, we will have an operation to increment it and to set it to a certain value. Finally, we need a way to check its internal value with some accessing function. So this is the shape of the API of the counter. It's interesting to notice that all commands are stateful except get. And it is also important that stateful commands don't return the value of the counter. So the only way to fetch its internal state is by using get. So if we want to write a unit test on this program, this could be a possibility. How can we represent this unit test as a state machine? It should not be very difficult. A state machine representing this test will have the counter state as the state of the state machine and the commands executed as transitions. First, the invocation to start initializes the state machine. Then we increment the value. The get command does not change the state. We set the counter value to 4. Again, get doesn't change the value, and the test is done. Viewing this, what do we need to test a stateful program correctly? First of all, we need some way to generate sequences of commands. We also need a symbolic state to track the evolution of the system. And finally, we need a way to specify how to interact with the program during the tests. Now let's take a look at how to test a stateful program using property-based testing. The first thing we need to do is to write the property that we want to check. The property we want to check looks something like this. This property is composed by two main parts. The first one is the command generator that will generate sequences of commands of a given state machine. In our example, we'll generate sequences of the commands available in the counter. The other part of this property is the function run commands. Run commands will execute the generated sequence against the program that we want to test. It will also check the result of every command execution against some predefined postcondition. Now let's take a look at how run commands works. Let's take the first generated sequence to illustrate the behavior of run commands. First of all, the increment is executed and returns OK. This result is checked against some postcondition. As we previously said, there is not much information we can check here, so the postcondition is always true. The next call is executed. This time is a get command. This time there is something we can check in the postcondition. The value returned by the call must be the same as the value precomputed by the symbolic state. Now it is time for the put command that sets the value of the counter to 4. Again, nothing that can be checked in the postcondition. And this is the last call to get that returns a 4, which is again checked with the symbolic state. And the test is finished. The place where all this behavior is specified is what we call a quick check state machine or a quick check model. So now let's take a look at the evolution of quick check state machines. The original way of defining quick check state machines was what we will call callback function style. It was developed by Kubik in their Erlang quick check library. The behavior of these state machines was specified using callbacks. The first callback, called initial state, corresponds to the initial state of the symbolic state of the model. In our running example, this is just the value 0. The second callback, called command, specifies how to generate symbolic calls to the program under test. In our example, we are only going to generate calls to increment, get, and put for the sake of simplicity. It is important to notice that arguments generators are specified together with the command call. In our example, we only need to generate integers input calls. The precondition callback specifies whether a generated symbolic call can be used on a certain state. In our example, we allow calling all commands in any moment of the execution. The next state callback is used to compute the next symbolic state after a given symbolic call. In our example, we have two functions that modify the symbolic state of the model, increment and put. The postcondition callback checks that the result returned by the program under test satisfies some predicate. In our example, the only command that can check something is get. That will check if the result returned after the call is the same as the symbolic state computed by the state machine. This first version of the quick check state machines presents some problems. First of all, contains some boilerplate code that can be automatically generated, but also makes hard adding new commands, requiring the programmer to rewrite the callback functions. These problems make these state machines hard to extend and to maintain. The next generation of quick check state machines was also developed by Kubik. These state machines move the focus of the previous callbacks to the state machine command. This means that the behavior of the state machine is defined in terms of the behavior of its command. In these state machines, each command should define a precondition that makes the command available. In our example, it is true for all commands, so we can omit it. A generator of command arguments. In this generator, the result should be put in a list. In our example, put is the only command that needs some argument generation. The callback pre is necessary to control the shrinking process. Since we are not talking about the shrinking in this talk, we will omit it. We also need a command that calls the real implementation. The postcondition callback defines the predicate that should be satisfied after the execution of the command. In our example, this is only necessary on get, as we have previously seen. And finally, next computes the next symbolic state, and it is necessary to keep track of the changes performed by the stateful operations. In our example, we only need a next definition on increment and put. This domain-specific language to implement state machines achieves really important improvements. First of all, reduces the amount of boilerplate necessary to write state machines. Also makes much easier to include new commands. Despite its improvements, this way of defining state machines still have some drawbacks. Errors in state machines are caught at runtime and are hard to debug, and still there are not built-in support for code reuse. So now we will take a look at Machina. Machina is a new domain-specific language to write quick-check state machines in Elixir. It was inspired by the state machine DSL available in PropCheck. Machina aims to improve development of state machines in various ways. First of all, we want to improve model quality with an earlier error detection. Also, we want to reduce the amount of boilerplate necessary to write models. In Machina, we want to improve maintainability of models. And finally, we want to make it easier to reuse code of quick-check models. To achieve these objectives, Machina will provide a new declarative syntax for command definition and state definition. It will permit automatic access to parameters and state attributes inside the command declaration. On top of this feature, we'll provide better support for typing state machines. And finally, we will introduce some built-in mechanisms for model extension and model composition to facilitate code reuse. So how Machina works? Machina is implemented using Elixir macros and exposes 3 macros that should be used by the user to define a state machine. Def state allows the user to define the attributes that will be included as the symbolic state. Def command is used to define commands in the state machine. And finally, the use macro, which is necessary to configure the module that defines the state machine. Commands in Machina are defined in the previously showed command style, but with 2 main differences. The command prefix is not longer necessary, and we decided to rename the command args2 to valid args to make it clearer. Now, let's re-implement our counter model using Machina. First of all, we must configure our model with the use macro. This will import the rest of the macros necessary to implement a Machina state machine. Notice that we use the implemented by construct. This construct allows us to redirect command calls to the module under test. During macro expansion, Machina will introduce the calls to the module where necessary. To define the symbolic state of the state machine, we will use def state. This macro receives as arguments a keyword list of attributes. Each of the elements of this list has the name of an attribute and its initial value. Optionally, the user can provide typing information to improve error detection. The last part of a Machina definition are the commands. Each command declaration contains the command name and its arguments. Like in state attributes, arguments in commands can be provided with type information. Finally, the body of the command contains the callbacks that define its behavior. So what are the advantages of this definition? First of all, it gives an easier interface to type specs, which is highly beneficial for the quality of models. By explicitly naming state attributes, they are widely accessible in commands. What is also true in parameters in commands. This has two main advantages. First, as documentation, and second, reducing the arguments in callbacks. The implemented by construct is very helpful to reduce the necessary code in state machines. Other important difference with previous state machines is the decision of using maps in the argument generation instead of plain lists. This is mainly to avoid ordered problems, but it also helps catching errors at compile time, if for instance an argument generator is missing. This is also applicable to the symbolic state, as with arguments it always uses maps. This allows, for example, to notice if a map is not correctly updated. So far we have talked about how Machina tries to make state machines less buggy, but we haven't talked about one of the major drawbacks of traditional state machines, their lack of extensibility. Machina provides two new built-in mechanisms for extending models. These constructs will permit us to separate different modeling concerns in different models and divide a model into smaller parts corresponding to each of its features. It also allows us to compose submodels into a bigger model. This way, a model can be easily maintained in parallel with a project that integrates features iteratively. And finally, it permits the reuse of models. These mechanisms are model extension and model composition. They will be developed in detail in the next slides. So what do we call model extension? We will say that a model extends another when it is written in terms of it. To illustrate extension, we are going to split our model in two models. Each of these models will be focused on a different phase of the testing process. We will call these new models generator and judge. We will start by the generator model. Generator is our base state machine. It focuses on argument generation and command execution. By looking at the example, we can see that the generator does not check any postcondition, neither changes the symbolic state, since it is not needed to generate new values. Now, we will write the judge model which extends generator. This model is focused on correctness checking, so it needs to keep track of the state changes using a symbolic state, and also needs to check the postcondition after calling get. So what is going on when a model extends another? Firstly, the state definition in the extended model is the union of all attributes. Secondly, the commands available in the extended model are also the union of all commands. And thirdly, callbacks have different behaviors when they appear both in the original model and in the extended one. If a command appears in both models, the definition of pre-args, call, or valid args in judge will override the definition in generators. The behavior of post is a bit different. Instead of overriding, when judge redefines a post callback, the conjunction between both definitions must be checked after the test execution. In addition to this, the user may want to access definitions from generator in the judge definition. This can be achieved using the super function, which is accessible in all callbacks. So this is the extension mechanism that Machina provides to the user. Now let's dive into parallel composition. Parallel composition will allow us to merge any number of models together. To illustrate it, first we are going to split the original model in three submodels, one model per command. With these three models, we can write a new composed model. To create a composed model, we need to use the extends construct again. This time, instead of a single model, extends will receive a list of models to compose. The result of expanding this macro will be a new composed model that follows some rules. The state of the composed model is the union of all attributes in the submodels. The commands available in the composed model are the union of all commands defined in the submodels. Until here, the behavior is very similar to extends. Things change when a command definition is repeated in various submodels. Postcondition of the callback in the composed model is the conjunction of all postconditions in the submodels. But this time, also valid args is the conjunction of all submodels callbacks. This is necessary to be able to shrink correctly a counterexample. The next callback will be defined as the composition of the next callbacks defined in the submodels. This means that the resulting symbolic state will be the result of applying the next callbacks of the submodels. The application of the next callbacks is performed in order of appearance in the list provided to extends. The precondition callback in the composed model is the disjunction of all the callbacks in the submodels. This is because we need just one true precondition to be able to generate arguments. The arguments callback will perform a random choice of the submodel callbacks. This random choice will be between the callbacks in which preconditions are true. Finally, if more than one implementation is defined for a given command, it is randomly selected at the execution time. The postcondition of a command can be refined by defining new postcondition in the composed model. This way, the resulting postcondition will be the conjunction between the postcondition of the composed model and the new postcondition. So we arrive to the end of the talk. As conclusions, we have to say that property-based testing has become very popular, but the state machines based on property-based testing are less common. We think that quick-check state machines are a really powerful tool for testing, but as we have seen, present some drawbacks that maybe are slowing down their adoption. Models are often buggy and hard to maintain. They don't provide an easy way to reuse code. In Machina, we try to address these problems by providing built-in support for type definitions and with two built-in mechanisms that allow code reuse. Finally, I want to remark that Machina is still a very experimental library, and we still are changing things on a daily basis. We have found some problems with our type definitions generated by Machina that were not spotted by the current type checking tools available in the Elixir. More concretely, has to do with types generated for the next callbacks and the arguments generators used in the state machines. We are not fully sure that the semantics of composition respect subtyping, and we also think that the new constructs are too expressive and permit the user to do things that he shouldn't. We are also improving Machina. For example, we are currently adding new operators that can be useful as command renaming. And finally, we want to revise the callbacks that are available in Machina commands, as some of them look intrinsically related, like precondition and argument generation. So that's all for the talk. Thank you for listening, and I hope you enjoy it.
Yes, thank you very much, Luis, for presenting this very interesting and inspiring work. I must say, I tried writing some tests for some state-based modules myself, and I found it pretty painful. So the approach taken by Machina is very neat. Thank you. So are there any questions from the audience that we can pick up? Also, if you want to just, if you don't want to type in all your question, you can also raise your hand and then we will invite you on stage and you can directly chat with Luis and me here. Okay, question from Lara. Out of curiosity, why did you choose to create a different library instead of extending or forking PropCheck?
This decision was made because we want to be able to generate state machines for proper and quick check. So Machina state machines, when the macros are expanded, they're both compatible with quick check and proper. So we want to be able to do this.
Mm-hmm. Very nice. It's always good also to have this interoperability with other tools, right? Mm-hmm. So what were, beyond this counter example, were there any larger programs or libraries that you wrote tests for?
We're currently testing smart contracts in Ethereum, and well, the whole idea of Machina appeared during this work we are doing there, because the libraries like PropCheck has some constraints when we needed to make really big models. So we focus. The first part of our work was trying to make extensibility of models easier, and that's why we develop Machina.
And maybe I missed it, but it's probably due to the integration with the PropCheck and so on. You are not tweaking the generation of the schedules or the sequence of calls, right? So this is what you
No, we rely on the other tools. We only do a translation between Machina models and other callback style function state machines. The ones that has this definition like postcondition, initial state. That's
okay. Other questions? Anybody? No? So I'm more of an Erlang user than an Elixir programmer, unfortunately, yet. Is there any chance of me using this in Erlang? So how related is this? How easy is it to maybe cross compile or cross use?
I don't know, because we are relying very hard on macros of Elixir macro systems. So I think it's not easy to translate it to Erlang, but we have to think about it.
Okay, so this probably means I really need to work on some Elixir adapters for my stuff and then write this. Yeah, makes sense. Okay. You have to write the property tests in Elixir for your Erlang systems. Yeah, it seems that this is indeed the future to go, right? So as Adolfo also found on Google, I think, it seems that Erlang, the interest for Erlang seems to be slowly decaying in terms of searches, but Elixir is doing very well. And yeah, as sister or sibling languages say, this indeed works pretty well. So yeah, eventually we probably all need to do something like that. Okay. Are there any, apart from the things that you mentioned at the end of your presentation, are there any features or so that you would find interesting or necessary in Machina to make it even easier to program the tests?
Well, we have found that there are some operations that we need to make it easier to compose and to extend models of tests. Like I said, we are now working on adding command renaming. So when you extend another model or compose any number of models, we want you to be able to rename these commands, so you can have different implementations of the same command in different models. And also, I think that type checking is not currently working great, but not this. It's part of our fault, because we don't fully understand Dialyzer and other type checking tools that are out there for Elixir. But we are working on it, and we are trying to improve it. Also, we found some problems with type definitions about parametric types in Elixir, and we didn't find a really good way to express this kind of relations in Machina. And we think this could even find more errors that we are currently finding if we have these type systems more powerful.
Yeah, I particularly liked also this aspect of being able to compose different tests into a larger testing infrastructure, but having some form of static help in that would be useful, I guess, right? But we got you covered. So if you have questions regarding Dialyzer, we'll have Kostas later here, so you can bug him, of course, with all questions and concerns regarding that.
Yes.
Okay, great. Seems that there are no burning other questions right now. We will also have the opportunity, I guess, to speak to you in the launch during the break.
Yes.
But before we move over to the break, we have a new feature now in the Erlang workshop that we started only this year, which are lightning talks. And as Staff was mentioned, we had already 6 submissions for lightning talks. And we will end this first session here now with 2 talks. Just trying to locate the speakers. So I'm looking for Susumu. And I thought I had, I have him here. Here he is. Great. So Susumu Yamazaki is joining us from Japan. I hope it's not too late for you yet. And you want to tell us something about expected applications of Beam ASM. So I think if you have slides or something, you are able to share them. The symbol is next to the microphone.
Okay. Please wait.
No problem. I'm doing very well in time.
Excuse me.
Yes.
I can't share screen. Present to audience is unable.
Is unable.
Disabled.
So you can't do the present to audience? Suppose any idea?
No idea, because it's enabled for us, and I don't see anything obviously off about your session. Let's see what we can do. Do you have a PDF presentation, perhaps, for slides, or do you?
Okay. I have a speaker deck URL.
Then I can share the screen for you and manage your slides, if you.
Okay.
That's okay.
Please wait.
Yes. Feel free to paste it in the chat.
Here.
Let's see. And I cannot see if I'm sharing the right thing, but I hope I am. Right?
Yes. Okay.
Let's see if I can make it a big and even
That's
better.
correct. Okay.
Better now?
Okay.
Perfect.
My talk is expected application of Beam ASM. My name is Susumu Yamazaki. Next slide, please. Next slide, please.
Next slide, Staffos.
No. Oh, oops. Can you click the bottom right button? Square button?
Was my screen frozen? So I'm now on the first slide again,
Okay.
as far as I can tell, and now I'm on the second one.
Okay.
No, you're on the first two for me.
Oof. Let me try to share again then. Sorry. That's what happens when you implement experimental features in conferences. But we will make it through. Let's go here and allow again. And this time I will not turn my full screen on to...
Not full screen.
Yeah, just to and hope that it will work. Sorry for that. Do you see my screen now?
Yes, but it's pretty small.
Okay, let's see if I can just zoom, perhaps.
Yeah, much better, much better.
Okay. Thank you.
Yes.
Then I'll talk again. Beam Asm is the Erlang JIT. Beam Asm provides load time conversion of Erlang Beam instruction into native code. Performance testing the JIT compiler for the Beam VM is amazing. For example, see right figure. Single queue performance is 45% faster than without JIT. Multi-queue performance is with JIT is faster, 30% faster than with JIT, without JIT. Okay, next slide, please. Then I propose expected application of Beam Asm. Next slide, please. First, code generator from enum map or NX to SIMD or vector instructions. Generating SIMD or vector instructions efficiently performs iteration with corrections such as enum map and NX. The right figure shows performance improvement by Pereme, which is a code generator from enum map with pipeline operators to native code, including SIMD instructions. Integer calculation, float calculation, and string replace with Pereme is faster than 2.25 times 4.448 times and 3.85 times than enum, respectively. Moreover, this is realized by a simple transformation rule, so Beam Asm can implement it without a heavy load of generating code. We believe we can get more improvement of performance if Beam Asm will perform such optimization. Next slide, please. Second application is application level optimizer that is embedded into Beam Asm. Specific applications such as calculating linear algebra, machine learning, and image processing require more performance. A general purpose code optimizer embedded in a compiler cannot generate efficient code because it requires application-specific optimization or knowledge, such as formula conversion and proof. Defining an application-level optimizer expects to bring more efficient optimization. For robustness, such an optimizer should be managed not to generate harmful code. This is a research challenge. Next slide, please. The last application is faster FFI than NIFS. We have found that the code that calls NIFS is often slower than the equivalent Erlang or Elixir code optimized by Beam Asm. Then EPC working group at EEF, see the right figure, faces this issue. We hypothesize that foreign native code embedded by Beam Asm will be faster than NIFS. Such foreign native code should be safe both in terms of type and execution time. These are also research challenges. Next slide, please. Summary and future works. Beam Asm brings more performance to Erlang and Beam languages. The applications of Beam Asm that we expect are as follows. Code generator from enum map or NX to SIMD or vector instructions. Application level optimizer that is embedded into Beam Asm, and faster FFI than NIFS. The application level optimizer and the faster FFI than NIFS have research challenges. That's all. Thank you.
Thank you very much. Also for pointing out the interesting open problems that remain to be tackled by the community and as mentioned by the Erlang Ecosystem Foundation in the working group.
Thank you.
Are there any questions we can pick up at the moment? If not, I hope that you will be available at the booth in a moment, such that we can discuss in more length. And trying to stick to the schedule, let's move on to the second lightning talk of today, which will be shown by Duncan Sparrow. And it seems that showing the slides is working for Duncan, right?
I think so. What are you seeing?
We see your PowerPoint open, but not in presentation mode yet.
Okay, let me get this out of the way.
So Duncan is going to bring some fun into our meeting here because he will be presenting something about quad-block quiz, which involves Elixir and quizzes. So I'm very excited to see how things will be going. Okay.
Does that look about the right size? Is that?
Yeah, I think that's good.
Wonderful. Well, hello, I'm Duncan, and I'm going to be talking about a game that hopefully you'll have some fun while learning some supply chain cybersecurity and why Beam OTP is so good for cybersecurity. The game is Quad Block Quiz. Save the Tetrominoes world from supply chain vulnerabilities. Quad Block's quiz is live right now at quadblockquiz.org:4000. The game is a mashup of quad blocks and a trivia quiz with some cyber attacks, licensing lawsuits, and cybersecurity thrown in. The game was introduced at the RSA conference, Supply Chain Village. RSA conference is the largest cybersecurity conference in the world. They needed a supply chain game, so I mashed up my passion for cybersecurity with my love of Elixir OTP, and I created Quad Block Quiz. The game was a hit at RSAC, and it was also a hit when it was reprised at B-Sides Las Vegas, a big hacker conference. It will also be used as part of an open course in cybersecurity. Quad Blocks quiz starts off as a typical falling bricks game where the arrows guide the falling of the brick. You get points for each brick. You get points for completing rows. Looks like I might be going to be completing a row here. Wait, what happened? A block changed color. Just like in the real world, vulnerabilities appear. Vulnerabilities are indicated by the yellow-gray block. A row is not complete unless it's free from vulnerabilities and some other troublesome blocks, including licensing issues, cyber attacks, and lawsuits. Now, you don't need to know the answers before you play. The purpose is to teach you supply chain security. Just read the page and you should be able to answer the question. Besides points, you get power-ups. For example, getting the SBOM question correct wins you the delete power-up, which lets you delete or blow up those pesky vulnerabilities. Correct automation answers win you the move power-up, which lets you move blocks into those holes. And the Phoenix power-up gets you rebirth, which clears the whole board and is really useful if you're attacked. I won't cover all the cybersecurity taught in the game, but one aspect I will cover is software bill of materials, or SBOM. Now, what is an SBOM? It's a listing of all your software components and their components, etc. There's a really lot of good information about SBOMs at nta.gov/SBOM, but I'll confess I'm biased. I was part of the group that created a lot of that content. Now, SBOM's been receiving a lot more attention since May 12th, when President Biden explicitly called for SBOMs in his executive order on securing supply chains. If you develop software, you should know what is in that software. If you purchase or use software, you should require your suppliers to know what's in that software. So to learn more, go to nti.gov/SBOM. And this game even has an SBOM, which was created using hex/SBOM. So you guys should put this in all your code. And for Elixir, the equivalent is rebar/SBOM, which does exist. Now, cybersecurity consists of confidentiality, i.e. private communications and data, integrity, i.e. nobody changes your data either at rest or in transit, and availability, i.e. the systems in your data are there when you want them to be. So pretty simple to say, pretty hard to do, as recent events have shown. Now, new work is showing that one way to achieve the CIA triad is with the DIE triad for distributed, immutable, and ephemeral, properties that the Erlang ecosystem naturally supports. Now, OTP was, when Ericsson developed Erlang back in the 80s, they put in the OTP libraries to provide a lot of DIE. So now OTP stands for One Tough Platform. Apologies, I keep screwing up my cursor. So let's talk about making the game. There's an easy-to-use Elixir web server known as Phoenix. It scales really well, making use of the Elixir lightweight processes, so it actually gives each user their own web server for each transaction. As a security geek, I really like that because it drastically reduces the attack surface. And because this game is a volunteer effort, I also like that Phoenix is known for its simplicity and for, quote, decreasing the cognitive load on developers, end quote, i.e. it's simple enough that even I can program in it and write maintainable software. Of course, I went one step further, and I started with an open source quad blocks project by Grox.io. Grox is Bruce Tate's company. Bruce teaches software development and uses the quad blocks repo to teach several different courses, Elixir, Phoenix, LiveView. I just forked the repo and added the quiz and cybersecurity aspects, so it can be used in cybersecurity courses, such as will be used by One Planet Education Network. So the one thing I want you to take away from this talk is that cybersecurity desires confidentiality, integrity, and availability. And to get cybersecurity, use the beam and OTP to get distributed, immutable, and ephemeral. I never say that word right. Now, don't misunderstand. You can still program bad security in Erlang or Elixir, but they are naturally support better security than most other popular languages. So what should you do now? You should go play the game. There's never enough time. Thank you for yours.
Thank you very much for your presentation, Duncan. This was very inspiring, and I'm looking forward to playing the game. Are there any questions, or is everybody now busy logging on and trying to get first results and placing themselves on the board? Nothing yet. I think it's interesting that you have the same impression as at least Vicky, who is later presenting in our workshop, also about security and how to identify interesting security-related parts of your code. And if I recall correctly from also previously talking to her, the way that OTP and Elixir structure the code makes it indeed much more viable to identify these places quickly and with some hope not to overlook things, right?
Correct. So there's sort of two levels to that. One is you naturally make fewer mistakes because the whole let it fail philosophy allows, I mean, all said and done, most hacker techniques are taking advantage of mistakes in people's code. Well, Erlang is designed basically to let you make mistakes and still work. So the hackers can't take advantage of it. And then the second layer is, as you just mentioned, all said and done, functional programming in general, but in particular, Erlang and Elixir, it's actually easier to see those mistakes that are the more, I'll call it design mistakes that hackers again take advantage of. So again, you can still make design mistakes in Elixir and Elixir and Erlang, but it's easier to find. It's less likely to make them, and it's easier to find them. So those are. I actually don't think our ecosystem does enough to. I mean, all said and done, cybersecurity is a really big deal right now, and nobody other than us realizes how good our stuff is, and we really should do a better job at basically teaching everybody else how to do this. And that's what I'm out there trying to do. And that's how I made the game. And I'm very involved in this software bill of materials effort. This new executive order that just came out is going to be, I think, really groundbreaking in changing the software industry. And we're really uniquely positioned to take advantage of that. People are going to start looking to, hey, don't buy $1 trillion worth of security gear to put on the end. Just write better programs to begin with. Oh, how do you do that? Oh, use Erlang and Elixir.
Yeah. I mean, it's really a pity that security is always added as an afterthought, right? And we know we should not do it, but people tend to, rely on other tools in order to prevent certain mistakes that could have been spotted earlier, or just addressed directly by the semantics of a library, for example.
Yeah.
Right. So one thing I got, maybe as a kind of last question from my side, I got slightly confused by when I looked at the title. So supply chain management, but for software, right?
Well, correct. So one of the big issues, so in the early days, hackers sort of directly attacked the program. People started getting better at being a little bit better, at least lately, in security. So what now hackers have discovered is I don't have to attack the program. I just have to attack the underlying libraries, because most software developers don't even know what software they're using. So I'm very involved in this effort the US government is doing in what's called supply chain transparency, which really means having a software bill of materials, which really means just knowing what software you uses and what software it uses and what software it uses. And most programs are actually very deep. They're 10 to 100 layers deep in their dependencies. And most of the attacks occur deep in those dependencies. So there's a lot of effort in sort of basically trying to secure up the supply chain of software. Most of the big hacks of 2021 were supply chain hacks. And that's what sort of prompted the issue.
Nice. Very
and again, so we're sort of buried, our ecosystem sort of buried in that infrastructure, and people don't realize it has way less problems than most of these other infrastructures. So again, I think we got to get the word out there.
Mm-hmm. Okay, I think there is one more question by Peter from Roy. So let's see if it works putting him on stage. Hi, Peter.
Hello. You can't see me, but my camera is supposed to be working, right?
Yes.
So my question is, you said deep, but you said that there's lots of dependencies that go deep from pieces of software, but also broad, right? So the number of these can be hundreds or thousands, right?
Or thousands, even as high as 10,000, correct. It is doable. There are companies doing it today. The financial industry has basically done it for years because obviously they don't want to lose money getting hacked.
Right.
They've been pretty private about it, so they haven't been sharing maybe as much as I would have liked. The medical industry has just started doing it and has some really major, really good efforts going there because, again, now people are literally dying because of computer hacks. And so obviously you want to prevent deaths, so people are doing it more there. The really good thing about it is, 80% of all software is open, some say higher, is open source. And for all open source software, you only have to do it once.
But
so
then you need to digitally sign it so nobody knows you've actually modified the binary or something, right? I mean,
well, okay, there's levels of attack. Yes, that is, just because you haven't signed it doesn't mean it's useful. It would be more useful if it was digitally signed, because then the next layer of attack is, like there was actually some big attacks this year that actually affected the development side of the supply chain. So yes, it would be better to do that also. But even one layer of SBOM, even one layer of software bill of materials, even without signing it, is better than nothing. Because it turns out there's been some studies done, and most people, once they actually see their list of things, realize they're using stuff they don't really need to use, or they have 4 copies of one thing, or they have 2 different versions of the same thing in their code. So sort of each layer of depth that you add adds value. Most of the big open source project, the Linux Foundation, is very big in this effort. So there's going to start signing all the Linux Foundation code, which, if you think about it, it's a pretty large chunk of the infrastructure. So if systems like Erlang and Elixir now have SBOM and now have the ability for developers to make SBOMs as part of their build process, you just include the dependency /SBOM and use it. Once you give that capability, the developers will decide their threat level. And again, yes, against the higher level threats, you need even fancier code signing and worry about man-in-the-middle attacks on your development systems. But those are pretty fancy. 99.9% of attacks aren't that fancy. I'm a hacker. I like to attack things. I don't need to get that fancy because people don't do the simple stuff. Let's do the simple stuff first, then we'll worry about the more complicated stuff.
Great.
Cool. I see some lively discussion continuing at the table in the launch. So thank you for all the speakers again that today so far gave the presentations and all the questions that we received and were answered. We will meet here back again in 25 minutes for the keynote on Dialyzer. So if you ever wrote Erlang or Elixir code, you probably used that tool, and I'm really looking forward to the insights that Kostas has. And so let's meet in the launch now at the tables, and back here in 25 minutes. See you then. Take care. Bye.
Cool. So we are back live again a few minutes before the scheduled time, just to get everybody slowly coming back in. Adolfo, I think so. The streaming should be working automatically. Can just go and check. Let's see.
Yeah, we are on YouTube.
I almost got the feedback loop.
Yeah, we do. We like living dangerous, right?
Yeah, well, don't provoke the gods again, Annette. We were chatting earlier with one of the students that were organizing committee today about how we are spread out, so it's hard for all of us to go down at the same time. And then Annette's university internet access actually dropped. So
Things happen, right?
yes.
But we are fault tolerant. We have everything sorted somehow. Yep, the session continues. It's again the same link, Adolfo.
2 more minutes until proper start of keynote session. One minute now.
Okay, because I like breaking. Oh, I should not do that, right? Should not do that. Okay, let's see. I just made a small poll just to see how polls work. But I'm not going to show this on stage because I don't want to destroy Costa's nice setup. So while we give 1 more minute for people to stream in, short poll. So which, it should be under conversations. Yeah, I guess first people found it. Which Erlang workshop is it for you? The first one, the second one, you attended approximately less than 5, less than 20. Which one is it for you? It's unfair, I can't vote. If you make a poll, you can't vote. Okay, great.
Aha, I cannot vote either, so neither of the hosts can vote.
Hosts can't vote.
But we cannot have influenced the outcomes.
Yeah, and I guess we're good to go, right?
Get on with it. All right, it's my great pleasure to be introducing my advisor, Costa Sagonas, who a lot of people have been searching in the Erlang community for the last few years, but I am able to find him and bring him to the stage again. Kostis has been present in the Erlang community since 2002 with evidence in public records, and I'm not sure if it's since 2001 even. He has been working over a long period of time. He has contributed to Hype, he has contributed to Dialyzer, a lot of other tools that are open source and available for everyone to play and extend and make amazing things with. He has been supervising a long list of great students who have gone on and done great things in the Erlang ecosystem. And he is with us today to talk us about 15 years of successfully dialyzing Erlang and Elixir code. So, yeah, the floor is yours, Kostas.
Thanks a lot for the introduction, and thanks for inviting me. It's very nice to be back in this community. My last, as Stavros said, my last Erlang conference that I attended was in 2018, actually in San Francisco. But after that, not much has happened in the Erlang world for me. This is a talk that goes back and explains a bit the history of how Dialyzer has been developed, and hopefully also the main ideas that are behind Dialyzer. It has been quite fun for me to try to find some old slides that I used in various talks about the papers that I will overview here and try to see them from a different, newer perspective. So this talk is called 15 Years of Successfully Dialyzing Erlang Elixir Code. And the reference to 15 years was from the Success Typings paper. But actually, Dialyzer, as we're going to see, is something that has been developed even before 15 years. So it's about 17 years that we have been working on that. So I would like to do a historical overview of how Dialyzer evolved. And hopefully we'll leave a lot of time for questions. If there is a possibility, feel free to interrupt me and ask questions while I'm talking, or post them in the chat. And I'll try to keep an eye there and answer them as we go. So, as we know, Erlang is a concurrent programming language. It has been heavily influenced by Prolog. It's a functional language, and it has been designed to be dynamically typed. Its main implementation is the Erlang OTP system from Ericsson, and has been used successfully in various companies, both in the telecom world and also in the internet world. There have been various successes. Now, one property of Erlang is that it's dynamically typed. It has been designed partly based on being influenced by Prolog to be a dynamically typed language. And in some sense, it can be seen as a unityped language. So there is only one type. It's term or any. So they are just terms. So in that respect, Erlang is there is no problem with types in Erlang. Everything is a term in one way of thinking about it. The problem comes from the fact that certain primitive functions are only defined on subtypes of all the terms. And their arguments need to be checked at runtime. So for example, addition is only defined for numbers. It's not defined for lists, for example. So there is an issue there. However, type safety is actually not an issue because it's provided by the runtime system. All the terms are tagged with a type, which is checked at all the primitive operations. So one has to understand that actually type safety is not the issue of types in Erlang. So Erlang is not like, for example, Haskell or ML that do not carry type information or mostly do not carry type information in the runtime. So there is an issue and the compiler has to do something there. Now, it is true, though, that programmers make mistakes. And they make silly mistakes, they make type mistakes, they make other kinds of mistakes, and we should help them in finding those mistakes and hopefully correct them before they are deploy the applications. So that's what we tried to do back in 2003 or 2004. We realized by working actually at the Hype compiler that occasionally the compiler that was doing some sort of type analysis was finding code that was obviously type wrong, type erroneous. So the question is, what should a native code compiler do in this situation? Generate what kind of code? So for example, you find that you have addition between a list and an integer. What code should you generate? So it was very clear to us that we can actually use the infrastructure that we had for the native code compiler to do static analysis and detect software defects. Obviously, we are not the first ones to find this or to come up with this idea. And this was actually the first paper that looked at using static analysis to find software defect in Erlang programs. And we wrote this with my student, Tobias Lindahl. And it was a fun paper to write and to read. I will just show you the introduction to see how fun it is. So as you can see here, the paper describes the architecture and implementation of the software tool that uses lightweight static analysis to detect discrepancies in large commercial telecom applications written in Erlang. And by discrepancies, we didn't want to call them type errors because we were not finding just type errors. We were finding exception raising code, hidden failures, other kinds of errors in Erlang programs, not just type errors. So if you are interested in reading this, I recommend going and reading the introduction. Is actually a bit strange for a scientific paper, but tries to do an analogy between software development and fighting a war against bugs. So the paper is written by this analogy in many places. It's not very deep or technical, but at least it described a tool that was doing something that then became actually the nowadays version of Dialyzer. So I actually found some of the slides. So I will show you here some of the slides of the presentation of that paper. That was the title slide. And it starts by saying that, okay, obviously, one way of finding errors is to go and impose a static type discipline in a language. And at that point where we wrote the paper, there had been various attempts to impose a static a type system to Erlang. The most well-known of them is the one by Simon Marlowe and Phil Wadler, who really should be credited by raising the awareness of what types can do for Erlang programs in Erlang. There had been some attempt by Thomas Arts and Joe Armstrong. I don't think that there was any paper written about that, but obviously there had been work on that. By Sven Olof Nystrom, also a short paper in the Erlang workshop of 2003, describing a soft type system that, as far as I know, did not really go very far after that. And some work by John Hughes and Karel Ostrovsky at the Erlang workshop in 2004. But none of them had been very successful at that time. And it's fair to say that they have not been particularly successful since then. So what we did in this paper is we wanted to use lightweight static analysis to identify software defects. For example, exception raising code or hidden failures that might exist in Erlang applications. And want to provide a tool that can be used to find some bugs in existing Erlang software and slowly try to encourage a different model of development of Erlang programs, where the programmer partially and incrementally specifies intended use of functions and their properties using type annotations or contracts. So that's from the paper, that paper in 2004. So of course it took us quite a long way to go to that point. And the weapon that described in this war against the bugs, that paper was a tool called Dialyzer. Dialyzer is a static analysis tool that found bugs, that can find bugs by simply pressing a button. It uses lightweight static analysis to find discrepancies in Erlang code, and these discrepancies came in various flavors. For example, call to primitive functions like addition that will always fail because they are called by some wrong type. Pattern matches clauses that cannot match and they are obviously there due to some programming confusion. Close guards that will always silently fail. So it had the various categories of errors that it could detect. The main properties of Dialyzer of version 1.0 that we wanted to guarantee is that we have no false positives. I was I very much insisted on this, that we should design some analysis that doesn't give you any false positives. And also that's completely automatic. So for example, the user should not be required to write any annotations, any type of annotations whatsoever. They should not be required to do any change to existing code. So they can only change code if they wish, because the tool has found them something that is obviously not a false positive. And sorry, and we wanted the analysis to work even with our source code. So at that time, there were quite a lot of applications, essentially, especially within Ericsson, that were closed source. So we wanted to be able to play with them and analyze them without having the source code. And we want, of course, the analysis to be quite fast. So, yeah. So that's the kind of analysis that we used back then in the first version of Dialyzer, a fast intra-procedural forward analysis that would propagate only type information forwards. That meant that we were assuming that functions could be called with any argument. So the arguments could have the any type, and the analysis would only propagate information forwards. So effectively, we could only determine the return types of functions because we're going forward within the function. And what Dialyzer did back then, it built a static call graph for all intramodular function calls. It analyzed this graph by constructing the strongly connected components so that we could analyze mutually recursive functions. And then we analyzed them in a bottom-up fashion until a fixed point was reached. So that's standard for those that know how static analysis work. Then we would build a similar call graph for all the intermodular calls. And based on this graph, we could analyze all these modules until fixed point. So pretty standard data flow analysis, really, nothing particularly deep. The interesting part is how do you do it for the complete language and how do you make it scalable. So we were doing the analysis back then on an internal representation that was used by the native code compiler called iCode. Probably not that many people know iCode and care about iCode. Probably you shouldn't really care. This was just our own representation. And in iCode, actually, it was an intermediate code where it had some type information. The type information came in the form of close guards, the pattern matching operations that were in iCode, and also implicit calls to certain primitive operations for which we had hard-coded built-in type information. So, for example, addition was one of them. We knew exactly what types addition takes, and also based on the types, what results addition returns. That's pretty much it. You could actually see how Dialyzer looked back then. It had a GUI. It still has a GUI, but I don't think that anybody is really using it. The GUI back then looked a bit different than the one today. So you could see that you could load the module somewhere here from a set of directories in your system. Then you got the messages that Dialyzer was spitting here when it analyzed all the code in that directory. And you got all the warnings down there. And you had this run button. It's really a push button technology. You could analyze only bytecode at that time. The source code was actually added later. And you could choose what sort of granularity you want, whether you want just a module or a whole application at a time. And whether you wanted to do just one pass and find all the easy to fix bugs or discrepancies, or do this until you reach a fixed point. And there was this first version of the so-called PLT. We could have a lookup table that was reinitialized per application or per module, or we could keep adding to the PLT as we were analyzing application after application. It's fun to see these things 17 years actually later. Yes. So now we had an analysis that we could apply to different kinds of applications out there. And then we had a way of manually classifying them as into 3 different categories, just because the paper had a fun title, war related, into explosives, camouflages, and cemeteries. And you can see these categories, just to give you an idea of what Dialyzer could detect back then. So we took various applications. This was at the time where the OTP system didn't have just a number to describe the version, but it had R for release, I guess. So this was at the time that we had release 9 of Erlang OTP. It had about 600,000 lines of code. We analyzed also the code of AXD301 and some other applications that were of a reasonable size and interest for the community. And we could find a number of discrepancies in them, and we manually classified these discrepancies into different categories. You could see that we could detect quite a lot of dead code. These are the cemeteries. But we could also find a significant number of places in the code base where there is a guaranteed exception that will be raised by the code if the code was ever reached. So back then we set this future work. So what we had done at that point and what we will be doing later together with Tobias, we wanted to analyze starting from source code, make a command line version for automatic inclusion in the development cycle and nightly builds, use the analysis results to automatically insert documentation into existing code bases, benefiting from user-supplied annotations, allow the user to relax the no false positives requirement, extend the static analysis to check for other properties, and also check the concurrent part of Erlang. There is a question on the chat whether AXD301 reaches 9 nines despite these extensions, explosions. Yes, there's no contradiction there. If you have it in code that is not particularly critical, or if you have a way of recovering fast from them, then you can, of course, do that.
So in this case, there's like supervisors on top of this code fixing it?
I don't
know.
It's conceivable that this was also in code that was never in the critical path. And actually, these were part of the stuff that we also wrote. You will see it in the next slide. So we had a successful tool back then. We applied it to literally millions of lines of code in well-tested and commercial applications and identified bugs that had gone unnoticed after years of testing. And we had the lightweight analysis, which was fast and scalable, and it required really minimal effort for the programmer, just to give the bytecode. That's all. However, there were also some disadvantages. The dialyzer gave absolutely no correctness guarantees, and also, in reality, the software defects that had been identified by that analysis were actually a bit shallow. They required fixing all right, but they were not really in the most tested and well used code. They were in code paths that were not so frequent. However, the point was that one should not underestimate the power of simplicity of use in a software tool. Tools that are very sophisticated, but they are very hard to use. They don't have much chance in the real world. And also the ability to identify bugs that are relatively easy for the programmer to understand and correct. Programmers rarely fix bugs that they don't understand. And actually, even today, even though I'm very amazed for people telling me that they don't understand dialyzer warnings, I can understand that there are people out there who, the first time they see a warning from dialyzer, they might not understand what it means, and it might require some effort from them to actually get into terms with dialyzer. So that's the first dialyzer version. Then we wanted to actually, of course, do some of the things we had promised as future work and try to make a more powerful version of dialyzer. What bothered me and what I was very much insisting on is no false positives, no false errors. And this was not because I had a issue with false positives, but there were quite a lot of studies out there in the static analysis world that false error reports are a showstopper for adoption of tools. And there are people that have written on this. Here are two citations. And the Escape Java people, the AC Java people had also written about this problem, that creating a tool that gives you even some amount of false positives, it can actually explode, and people cannot really use it. Also other tools, other studies reported similar things. Okay, so the question is what to do next. So of course, one can say, okay, let's impose a type system. And what's a type system really? It's a static analysis really that is fast, relatively fast, and it's sound for correctness. So the slogan there is that well-typed programs do not go wrong. Of course, it depends on what you mean by this, but because the type system only finds a certain kind of error, okay, doesn't tell you, for example, that your program will necessarily terminate or that will not have a division by zero. You can perhaps design type systems that give you these properties, but you might not necessarily want to use them. The main problem is that a static type system is actually pessimistic and inflexible. If it cannot prove type safety, then it needs to reject the program. So that's my impression of a static type system. You have an armor. It protects you from various things, but you cannot really move very fast and be particularly flexible in what you want to do. Also, it seems a bit old-fashioned for my taste to be working around like that. So we wanted to do something better than that, something different at least. And the question was what? So let's take a break, and I'll tell you a story about restroom signs here that perhaps some of you have seen before, but it gives you some food for thought. Here, how the restroom site might look in many places, or in most places in the USA. Okay, you have a sign that says women, a sign that says men. Back when I went to the National Technical University of Athens in Greece, the signs actually in the restrooms look like that. Okay, so of course you can see the difference between the two. And of course, a tempting conclusion, just for fun, might be that in the USA, everything is forbidden unless it's allowed. And in Greece, everything is allowed until it's forbidden. But that's not the point, really, of the story. The question is, which of these two things do you think is more permissive or less permissive? Take a moment to think about it. Which is the proper way to have restroom signs? And actually, it's a very difficult question to answer. So, for example, this one is more restrictive. As Brujo says, dogs cannot go to the bathroom in the US. Okay, so it's restrictive in that sense. On the other hand, it's a bit more permissive in some other sense. So, what about if you're both? For some definition of both, at least. So, also, on the other hand, it's too restrictive. What if you are neither of these two categories? In exactly the same way, so these signs at the NTUA, so they are in some sense more permissive. What if you are, an extraterrestrial that just happened to come by, or a robot, as Laura says? So on the other hand, it's too permissive. The dogs are allowed to go anywhere they want. If you are both, you have a problem here. You cannot really enter anywhere. So the point is that it's all a matter of desire. Neither of these two ways is better by default. It depends on what you want to do. And in order to actually say something intelligent about which one is better, you need to use some metrics for quality. And the metrics for quality is the precision and the recall. What percentage of the allowed behaviors or the behaviors you want to allow are the desired ones, and which percentage of the desired behaviors are the allowed ones. So that's the analogy here with what we designed the ELYZR. Okay, so the moral of all this is that designing static analysis, which is sound for correctness, is perhaps a very good thing in some situations, but it's not always a superior approach. It restricts expressiveness, and it might reject programs which are valid, for some definition at least of valid. It all depends on what you want to do with it. And the goal of the ELYZR has always been to be a defect detection tool, not a tool for correctness, to prove correctness. So the goal was to find definite bugs. So, so it's soundness for defect detection, Peter. So soundness for when the tool tells you your code is incorrect, it is incorrect. Of course, with caveat that you will actually execute your code. That's a problem for any static analysis. So if you don't execute it, will not have a problem, right? So no false positives, exactly, no false positives. And that's exactly what success typings tries to do, which of course was very heavily influenced by something that I knew from my logic programming background called success typings, the success set of a predicate. And we will see how success typings will come, how they are related to relations, really. And we wrote this paper with Tobias, published at PPDP 2006, where we introduced the idea of success typings. The main point of this paper is to try to look at to design a system that does type inference, but on the other hand, it never gives you false positives. And it had a quote by a song of a Swedish group that is called Dressed for Success. So I will try to explain a bit the idea here. And the point of that paper is to do complete type inference. So no real type annotations at all. Okay, so this was back before the times where Erlang didn't have a type language. You could not annotate anything with types. So it's full type inference. The inferred types should be easy to interpret by the programmer and never lie. Never lie, in my mind, meant we need to capture all the possible, however unintended, uses of functions. Okay, but so we need to capture everything that you can do with a function. And of course, we wanted a type inference that was completely automatic. It does not require any user annotations. It does not require even type declarations. And of course, also we wanted to handle the cases where not all the code is available. And there are situations where not all the code is available. And last but not least, we want to be relatively fast. Whether we succeed on that, you can judge for yourself. So the basic question that you need to answer when you design something like that is, what do you want to be the inferred type of this function? Okay, so what do you think should be the inferred type of this function? And it's like the restroom signs. There is no universal truth here. For some of you, this function might look familiar. For some others, it might not look familiar. You have somebody who is a programmer other than you might have written it. So you cannot say what the programmer has as intention here. So one possible type that you can say, yeah, it does smell like append indeed, but it's called foo. So how do you know what foo will be doing? So one possible type that you can give is any to any to any. Okay, so you can call it with anything on the first two arguments, and it will give you anything. Okay, so that's okay. It's like treating Erlang as a unit type language, but it will not take you. It will not take you very far, right? You cannot expect to find many bugs like that. So another possibility is to say this. Okay, so this obviously in most of the cases returns a list. So let's say we're going to say it takes anything. We can call it with anything and anything, but it will return a list. That's a bit weird, but okay, you can find that perhaps this makes your analysis find some bugs easy. Another one is to say this. It smells like append, as Peter said. So let's call it append. and let's say that should only be used with lists, and then it returns a list. So, but there is a possibility here that you can choose all of these things or something else. Now, none of these things actually is a success typing. What success typings are trying to do? None of this, okay? Of course, there's something else is, but these three things are not the success typings of this function. So in order to understand what success typings does, we need to look at something more, in my opinion, fundamental, which are the operational semantics of the language. So it needs to capture the operational semantics of the language. And the success typing is this, of this function. It takes a list. You can definitely see that this function will crash if you give it something other than a proper list in the first argument. But there are situations where you can call foo with the empty list and 3.14, and this will give you 3.14. And it's not just with floats. You can call it with something else, with binaries in the second argument or something else, and it will give you the something else with an empty list. Okay? It's not only with an empty list, it will give you something which is an improper list if you give it something that is not a list in the second argument. And a non-empty list in the first one. Okay, so that's I think if you understand this slide, then you probably understand what success typing is trying to do. And we wanted to do that because, of course, we didn't want to just type append or foo, but we wanted to not get into trouble. And there had been at that point sufficient evidence that other people who are perhaps more clever than us got into trouble. And here's the example. You can write in Erlang, if you want, this implementation of AND, of an AND function. So end of true and true is true, and end of false and anything else is false, and end of anything and false is false. And of course, you can declare a type called Boolean, which is either true or false. You can see its operational semantics here. And the Hindley-Miller signature, type signature of that one, of course, is that this is a function that takes Boolean and Boolean in the terms of Boolean. That's what Hindley-Miller will give you because Hindley-Miller has some strict requirements. For example, that true and false only belong in the Boolean type. Now, if you want to design something for Erlang, Hindley-Miller is not enough. So you need to go to something else. And the one attempt to go to something else, to go to a subtyping-based system. But then you get into trouble. The subtyping systems that Simon Marlowe and Philip Wadler designed was actually typing this function correctly in some sense, but weirdly in some other, that it takes anything in the first argument, false in the second argument, gives you a Boolean. So if you ever call end with anything other than false in the second argument, they will tell you that you have a bug in your type error in your program. This is not particularly usable after a while. And of course, you can perhaps fix it with end by rewriting the end function somehow differently, but it doesn't really scale. So let's look at how what does it really mean to do success typing inference, okay? So this is the dynamic type domain, the domain for which the function actually will work and return something according to the operational semantics. So what static typing systems are trying to do is they try to restrict this. Okay? So they need to guarantee correctness. So by definition, they have to put some restrictions on what is allowed according to relate to what is allowed by the operational semantics. But in success typing, we need to go the other direction. We need to capture all the dynamic domain and then some. So that's the definition we came up with. A success typing of a function f is a type signature, or some types a bar to alpha bar to vita, such that whenever an application of f with some particular terms, p bar, reduces to a value v, then this v necessarily belongs into the vita set, and the p bar belongs to the alpha set, to the a set, to the alpha set. Okay, so that's a very relaxed definition. It allows many things, but it captures the basic intuition of dialyzer, okay? That if the arguments are in the domain of the function, the application might succeed or it might not. But if they are not, the application will definitely fail. So we are capturing here definite failure, definite errors. Okay, so the slogan of Dialyzer is that wrongly typed programs will definitely fail here, not that well-typed programs never go wrong. So we are going in the other direction here. We are approximating the dynamic typing from above. We are more relaxed. And that's what Dialyzer tries to do. So how does it work? So the success typing we're going to derive for the end function, for example, is that we can call it with anything in the first argument, we can call it with anything on the second argument, but if it returns, it will definitely return a Boolean. And you can see here that this is okay in the way that the programmer has actually written this end function. We cannot say that the arguments will be necessarily Boolean. There might be something else. There might be 3.14 and false, or false and 3.14. But definitely, if the function returns something, it will be a Boolean. So there are two different sides to the story. They're complementary. On the one hand, the static typing view says that well-typed programs do not go wrong, and it's a pessimistic system. If we cannot prove type safety, we must reject the program. The success typing view says that ill-typed programs will surely fail. And it's an optimistic system. If you cannot detect a type clash, we need to accept the program. But it allows us, this view allows us to find definite errors. And that's the whole point of Dialyzer. Now, inferring success typings, of course, it's trivial in some sense, because you can always infer the any-to-any success as a success typing. But you obviously do not want to do that. You want to do something better than that. And the whole aim of the algorithm that is described in the paper and has been refined since then is to reduce both the domain and the range of the success typing as much as possible without excluding any valid terms, without excluding terms for which the function will return, will succeed. Now, it's a constraint-based algorithm. I will not describe it in detail, but it uses constraints in the bottom-up function per SEC. In contrast to the first dialyzer version, which used the forwards analysis, the constraints are organized as disjunctions and conjunctions of subtyping constraints. The conjunctions basically come from straight line code, from when you use comma in Erlang, and the disjunctions come from the case statements, the choices that exist. These are better explained with some examples. So let's say that I have this A function here. This function will be what we will infer, because we know information about the plus built-in function that only works with numbers. We are going to infer that this A function takes either an integer or a float, and returns either an integer or a float. And notice that, for example, we are losing here. In the most basic version, we are losing information that, for example, if you call it with two integers, you will get back an integer. And if you call it with a float and an integer, you will get a float, and so on. So already here, success typings lose some of the information. You can recover some of them by doing some more advanced type representation, and we experiment with them, but it seemed that we did not really gain that much. However, let's say that we have this representation, and we have inferred that A takes either an integer or a float, and returns either an integer or a float. And then we use this A in some other function, B. But this B has a guard that says, I will only use this clause when my argument is an integer. So what success typings will infer for this function is that the function will only succeed if you give it an integer, and then it will return you an integer or a float. And it approximates this one, obviously, from above, as you can see, because it has lost this information, as I explained, about what addition really returns. But the interesting part comes afterwards. Let's say we're using this B function now in some other function C, and we have a case statement here where we are matching against 42, Gazong, and 3.14. What the success typings will infer for this function, based on the fact that B only takes an integer as an argument and returns integers or floats, it will tell you that C, its type that it infers is that it will only succeed if you give it an integer, and it might return you foo or buzz. And now, with this information that has been inferred in a bottom-up fashion, as you saw, we can detect that there is a discrepancy here. This clause with Gazong will never match. But we do not detect the discrepancy here, because C will never return really a floating point number. Okay? So no, it does not infer negative types. There is a question whether infer negation. So it infers negation indirectly. Like, for example, C here will only return if you give it an integer. So if you don't give it an integer, obviously this function will fail. Okay? Okay. Two more examples. Here is a function that shows you that you can mix primitive types. And of course, what success typings will infer is that if you give it an integer or an atom, this function will return something. And that something will be an integer or a list. And finally, the last one, which is the no success typings. There is the none here, that Gazong will never really return no matter what. okay? So it will always throw an exception. That's it for success typings. So it has no local return, indeed. So a slight disturbance with what I have described so far, which was very clear to us from day one, and it's in the paper, is that you have the length function, for example, and success typings will actually infer this type for them, that length takes a proper list as an argument and will return you a non-negative integer. Notice that this is a bit more refined than what most type systems out there for Haskell or ML will give you. But if you rewrite this function to make it telerecursive, for example, then success typings will lose some information. It will tell you, for the same reasons that we had for append, that this length 3 function here can take anything in the second argument, and of course then it gives you anything, and that propagates in a bottom-up fashion to the length 2 function. So this is a bit disturbing, so we want to do something about it. And indeed, as Peter says, we can use the module system. The module system here is what saves the day. In Erlang, it's a language where you cannot really bypass the module system. The code resides in modules, and the modules have declared interfaces, the exported functions. So since the module system protects local functions from arbitrary use, we can collect all the types of the parameters of all call sites of these functions, and we can restrict the success typings to only those types of the parameters. And this is what's called refined success typings. And if we have this module where only length 2 is exported, notice, Peter, and everybody else who is paying attention, that this assumes that you cannot call length 3 from somewhere else. So you need a closed word assumption, basically, to infer that length 3 is only called from 2 places. And that's what the export function, the export declaration gives you. It says that length 3 here, because it's not exported, is only it's only called by these places. So if it's exported, you have no guarantee that you have all the call sites, so you cannot do the specialization. It's fine for length 3 if you call it from somewhere else, to call it with the empty list and the 3.14 in the second argument. It will happily return 3.14. So you cannot flag that call as erroneous. So you need the module system, trust me. So rather than inferring these types here, you can specialize this based on the call sites and infer that the second argument of length 3 will always be a non-negative integer, and that gives you a non-negative integer, and you can now propagate this in a bottom-up fashion to the length 2, and you can recover the type information that you lost when you did the rewrite to the Taylor recursive version. Now, the good news is that then you can play other various tricks, and you can make this algorithm stronger and stronger and stronger and stronger. And that's the good thing about success typings, that it will, you can always make it more refined, more refined, more refined. So this is, I hope I've given you a good, I'm running a bit out of time, so I hope I've given you a good overview of the ideas of Dialyzer. So the characteristics is a tool that is sound for defect detection, not for correctness. So hence the slogan that Dialyzer is never wrong. The dialyzer will never flag something as an error when it's not an error. This has obvious advantages, in my opinion. Obviously, it has disadvantages in the sense that you don't find all the possible errors. On the other hand, it's a push-button technology. It's completely automatic. It scales to large code bases. It's widely used. And I think I can claim that it has been very successful in its community. You can go further than that and add specs and make the algorithm even more expressive and refined based on the specifications that you give for your functions. So for example, you can give specs. Notice that now the programmer writes the spec. All the other things that I have been described before, they were just inference. And the specs can be checked by a dialyzer. And if it finds discrepancies between the spec and the uses, it will tell you about it. Or you can even add contracts. You can make the specs more restrictive than what they actually are. You can, for example, say that I will only, for some reason or another, I only want to call my length function with lists of atoms. And dialyzer now will flag you all the places where you don't use lists of atoms in the length function. I'm running out of time. Last two slides. Here is how Erlang looked when we started. Here is how Erlang looks today. Because of dialyzer, I would say, and because these things could be done gradually, that you didn't need to change all your code base and add types and specs. You could do it one module at a time, and dialyzer would help you in that. I'll skip some slides about opaque types, and I want to thank you for your attention because it's exactly at the hour here. So you can open your mic.
Yes. Thank you very much for the presentation, Kostis. It really shines a light into all the thinking of dialyzer and yet more. I'm sure that people would appreciate if you were to go through the rest of the slides in the break room, in the lounge room. I am wondering if anyone has any questions that they want to bring up live.
There is a question by Fred. I guess that I was thinking that you could infer the type of AX is an integer if X is an integer or float. Yes, you can actually do that, and for built-in functions, actually dialyzer does that. So I was slightly lying there. But if it's not a built-in function, it's actually more complicated than that. And actually Stavros, who is chairing the session, has actually worked on this. And there was an experimental version of dialyzer that was not just finding unions, but also finding intersection types. We could detect some more discrepancies that way, but not really that many. And the analysis was much more complicated. You can ask Stavros how much complicated it is. It was.
Happy to talk about it in the break.
Yes, we can talk in the break.
There is something posted on the Q&A tab.
Yes, let me check that too also.
Duncan is asking, so back when you wrote the paper, did you take any grief for less academic text?
Which of the papers?
The one, I guess, about the war story.
No, nobody complained back then. The paper was accepted immediately. Well, if I remember correctly, we didn't have any complaint on that.
And having worked together with Kostis,
it was very. I think this is a fun paper, but actually it's not particularly deep, to tell you the truth.
Yeah. And even if he did get this kind of grief, I can guarantee you that he did not stop writing this kind of papers. And you can find many such examples there of this.
So looking back at this decade and more of Dialyzer, if you had to redo the work, would there be anything that you would change?
That's a very good question. Obviously, there are things that one can change, but the nice thing about that approach is that you can actually improve it. You can go from the other direction and make the inference stronger and stronger and stronger. There is one more thing that has never been implemented, some optimization in the type inference algorithm that has never been implemented that one can do even in Dialyzer today. I don't have time to talk about it right now, but taking the specs and using the specs that the user has given in a more aggressive function that they are used today. So that's the thing I would be doing, but it's not really different. It's an improvement.
Mm-hmm. Yeah, I mean, that's probably a technical thing. One thing that came to my mind, I mean, I also know people, particularly first learners of Erlang, that come from statically typed languages to Erlang and then fall for the trap that they expect Dialyzer to be, you know, a static type checker that works as other static type checkers. Would you maybe, I mean, is it reasonable maybe to rename Dialyzer to kind of, I mean, should I reformulate that? If I had the expectation that it was a static type, a static checker that would just check for inconsistencies, problems, and so on, it's probably doing exactly the same thing, but maybe not raising these expectations and being so closely related to the classical Hindemith type checking algorithms. Do you think this would make a difference?
So, to me, the basic problem is that Erlang has some very clear operational semantics. And, you know, unless you change this operational semantics, you cannot impose a Hindley-Milner-like type system. Because, you know, there will be programs, of course, for which you will find more type errors, but then there will be programs that are very legal and people are writing out there in Erlang that you will not be able to accept. And the question is, what do you do with these programs? So one thing that I would be doing, not differently, but I would be insisting a bit more when I was in close collaboration with the OTP team, is to have a lightweight version of Dialyzer run as part of the compiler. They never wanted to do that. And I never understood why, if it's an option. I understand that Dialyzer is not the fastest tool out there. It can be made faster. Actually, they have slowed it down. Stavros did an amazing job in making the analysis running parallel. And this part of this thing was actually lost on between the years. Hasse Bolinder, who is, by the way, has done a very good work maintaining Dialyzer and extending it and fixing small bugs here and there, has done after that, but unfortunately he destroyed the parallelization parts of it, at least. I hope I made sense.
Totally, yeah.
And there's more, Brujo has a question asking you who Eli Fragaki is, and I think you can answer him in the lounge with all the information of her. Let's give an opportunity to the Lightning Talk speakers to to have a chance before the break.
So I know very well. By the way, one slide that is not shown is Dialyzer. I think I can claim most of the credit for the ideas, but most of the credit for the work of Dialyzer goes to various people. First of all, Tobias Lindahl, then my amazing students like Stavros and Eli, and Manuk and Ipatia, and other students that have worked on Dialyzer at various points and have made amazing improvements and bug fixes and so on.
Great. All right, Kostis, thank you very much. Everyone, you will definitely have more time to question him about everything that is well or not well with Dialyzer during the breaks. And let's move on. We have a lot of slack time, so that's why we have let Kostis go on a bit beyond his slot. So we are now taking advantage of this slack time, and I'm going to invite on the stage Anatoly Kosorukov, who has promised us a lightning talk on using regular expressions in Erlang.
Hello, I am Anatoly Kosorukov from Kaliningrad, Russia. I would like describe a little bit remodel of Erlang ecosystem and present you what I have found while researching that library. Let me share screen. Can you see my presentation?
Yes, we can.
Yes.
Oh, super. I'm start. I'd like to share my experience of using a regular expression in Erlang. This is the plan of my short talk. Regular expressions are great when you need to pause the text, replace one text with another, or break it into parts. To solve this, you need re-module. Regular expressions in Erlang are based on the functionality of the Perl-compatible regular expressions library. The documentation for re-module is very extensive, very huge, but unfortunately, it only generalizes some main regular expressions options. Probably because of this generalization, some features are not described in the documentation, but nevertheless, they exist and work in Erlang. For example, I discovered that, like Microsoft.NET and Java Standard Library, the re-module provides the ability to use union, intersection, and subtraction of character classes. I've checked how it works in Erlang using eUnit tests, and it turned out that this functionality is compiled and runs completely as it was expected. Despite the fact that regular expressions significantly reduce the time for writing code and reduce the complexity of the code, I have to say, there is no books on regular expressions in Erlang. That's why developers themselves have to apply experience, ideas, achievements of the regular expressions experts to the possibilities of re-module. As for me, I reconsidered the material of such books as Michael Fitzgerald's book Introducing Regular Expressions and Ben Forter's book Learning Regular Expressions, and also some others. I reconsidered their material and thus have created Reba 3 projects for Erlang. This is one. As a result of this research, I have implemented a number of helper libraries, which I posted on hex.pm. Here you can find everything I've just talked about. Thank you for your attention. You're welcome with your questions.
Anatoly?
Yes?
Is there some question? Oh no. Yeah, on the side, I am trying to check the program and see something that is confusing me.
What?
Trying to figure out whether we need to recover some time after our lightning talks. But yeah, thank you very much for your talk.
Thank you.
We'll check it out.
Yes, we'll check the library out and talk to you more in the lounge area. We have one more lightning talk for this session, and this comes from Marcel Lantz from eigr.io, which is a serverless runtime on the Beam. And Marcel, you're with us on the stage.
Yeah, hello. Thank you very much. So it's called Eiger. It's a misspelling of the Eiger mountain in Switzerland. So it made a nice name to be used for an open source project.
I played it safe by just spelling it since I didn't want to get it wrong. But thank you very much. Eiger.io. Yeah.
So I share my screen. Yeah. So do you see my screen?
Yes, we do. Not in presentation mode yet. No. If you want to do that.
I couldn't test that in advance, so perhaps I can share my whole screen, share screen, and entire screen. Hello. Now? Yes?
Okay. Yes.
Can you see it?
You need to switch the tab, I think. Yep. Well.
So it should be a PowerPoint presentation.
Let's see if it's getting...
Yeah, perfect.
Yes. Okay. And
okay.
Yeah. We'll let you know if we cannot see your next slide because it clicked on me earlier.
I can test the next slide. This is the next one. It's okay?
It works fine.
Okay,
so
thank you very much.
Take it away. Yep.
So hello, thanks for having me here at the 20th ACM SIGPlan Erlang workshop 2021. I'm excited to talk about a project I and a few collaborators have been working on for the last couple of months. So for the agenda today, I will, in this talk, I will give an introduction why we started the Eiger project, why we think serverless runtime is relevant these days, and what we are currently building on as an open source project. I will talk about some technical highlights we have, and I'll go into the current state and challenges we are working on, why we think the Erlang system and the Beam is a perfect match for this project. So first, what is Eiger functions? We named it Eiger functions. It could be another name, but it's actually one of these principles that we have on other serverless runtimes like Amazon Lambda or Azure Functions. And we aim to be a serverless runtime, and that allows to enable the development and building of general purpose applications. It is an open source project. We are based on another open source project that is inactive at the moment. It is the Cloud State protocol or project, and we implement at the moment mainly a so-called service proxy for it. As said, it is based on a protocol. This has some advantages. I will explain this. And we have so-called polyglot SDKs. So we can provide SDKs for the most relevant languages that exist today to implement business logic for this serverless runtime. So for the technical highlights, there are 3 or 4, as you will see, but the 3 from a technical point are we have a service proxy that manages state also. We have a cloud native deployment story that runs on Kubernetes. Then there is a protocol that is gRPC based. We have a spec and a TCK. And as said, the programming model is a polyglot. There are SDKs with support for the most major programming languages in use today. And it runs on the Beam, which is nice, I think. So, and I will come to the first highlight. This is a service proxy. So there is a simple pattern actually for a service proxy, that is message in and message out. So we can think of a service proxy as a component that gets messages. It delivers the messages to a handling function in our case, and then it spits out a message again. So it's zoomed in, this service proxy or this service can be depicted as we have it now in our implementation. So there are 2 containers. These are Kubernetes, run on Kubernetes in a pod. On the left side, we have the possibility to access the proxy on HTTP, gRPC, and also PubSub, publish subscriber infrastructure. And we do some we do state management and replication, and we are communicating with the functions over gRPC. So this is the protocol that is spoken between the service proxy itself and a function that is implemented here. It could be in Go or in Java or Python, and the most popular language would be JavaScript for sure. Yeah, so this is the overview of how it is laid out. Our project is implemented in Elixir, and we also have a Kubernetes operator that injects these service proxies as sidecars beside a user function, a function that is implemented in this environment. There is something special. It is also special about the Cloud State protocol, and also in our project. So usually function as a service architectures are stateless. So if someone wants to have state in a stateless environment, it has to access a database as an example. But here we have something called inversion of state. So we bring the state to the function. So this is an example. Here comes a request in. It gets state that is already there. I will explain how this works. It goes to this function here on the right. So there is a context where the state can be accessed. Then there is the original request as a message. The function that implements the business logic, as an example, then responds with a response. And it also gets out change state if the function has state changed. And a state management component will handle this state outside of the request or invocation of the function, and the client that requested gets a response. There are different state models to choose. So this is a compromise where the user or the implementation of a function has to choose a state model. So there are action model, event sourcing, CRDTs, and value entities. It's like CRUD. It's a common CRUD model. Next, there is a protocol to use. ICA functions implement the Cloud State Protocol. It abstracts state, and the state models are defined in proto files. These are protocol buffer files. It is quite commonly used in cloud and cloud native and projects, and it has some advantages. One is it is based on HTTP2 and has a streaming support, and the specification for the protocol itself can be defined in protocol buffer files. Last, we have here a TCK, a so-called TCK. It is a technology compatibility kit. It ensures the compatibility of implementations of SDKs and also the proxy. So it ensures that the protocol between the components is valid and correct. One of the advantages to be gRPC based is we can have support for multiple or all gRPC enabled languages that are out there. So if there is a gRPC compiler, we can have an SDK or support for this language. So even if the serverless runtime is written in Elixir or running on the Beam, we don't have to implement user or business logic in Elixir. We can implement it in JavaScript, Java, or Go as an example. And all the languages I listed here are possible. So this is very interesting. We have support with high coverage, 100% actually, for 3 languages at the moment. And the other languages are coming from the community, also from the Cloud State community originally. And it's a great advantage to have these other languages available, and everyone can choose his favorite language. So current state we have and challenges. We have a service proxy in Elixir implemented. Our first challenge was to implement gRPC reflection that was not available for Elixir. And now we have, since a few weeks, we have a discovery and action protocol implemented. Our next challenges will be to implement state models, to improve SDKs, and enhance the TCK. So one interesting property of this project is actually to have developers and contributors that can write in different languages. So you could imagine if you have someone who is proficient in Elixir or proficient in Java, if someone comes and knows a lot about Python, he can contribute to the project even if he can't write or contribute to the open source project because he can't write Elixir. So it's an interesting aspect of this project, I think. So with this, I come to the end. So I said we are an open source project. We are a welcoming community. We have this Discord channel that is quite active, and I invite everyone to check it out. And if someone wants to join or help us with our challenges, I'm happy to help, and we are happy to introduce our project to them. Thank you much.
Thank you very much, Marcel. Very interesting project, and very in a direction that is really popular today. as there is a question from Fred. I can also invite him to the stage if he wants to participate in discussion.
Yeah, great question. So, yeah, I don't know if it came clear with my presentation, but one of the, I think, coolest function is we can have state in stateless usually in a stateless environment. So function as a service often is stateless. And yes, the service proxy has to handle the state for the function. So yeah, we use Erlang with his functionality to build a great distributed system. And yeah, it's correct. It is a state manager for the function. So do they do state management as well? So the user functions don't. They choose a model. So if you implement a user function, you choose if you want to have event sourcing or if you want to have CRDTs as a state model. So CRDTs are it's replicated. It's a model to replicate data conflict-free in a distributed system, and they are very attractive from certain point of view. And the user function has to choose it. So this is the compromise you have to. You don't implement your state model by yourself. You get it managed, and you have to have chosen which one you want to use.
Thank you very much for the presentation and the answer. So we are supposed to start pretty quickly, but we will take a short 5-minute break since we have the leeway for the next session. And we will resume in 5 minutes. If the presenters of the next session want to stay behind, we can check with them that they can join the stage and present and have everything in place. But otherwise, I will click the take a break button and call everyone back in 5 minutes so that you get a notification and a pop-up if you go to the lounge. See you soon.
Okay.
Can cancel anything. I think we can fix that here.
Okay, just a second.
Okay,
Yeah.
welcome back after this pretty short break. We will have a longer one after the next session, I promise. So Costa set a very nice setting now for the next two talks for technical papers that will also deal with different types of code checks. The first one is by Pruvo Benavides and Laura Castro on detecting Oxbow code in Erlang code bases with the highest degree of certainty. I hand over the microphone to Pruvo. Enjoy.
All right, so I am Brujo, and I wrote the paper. I always wanted to say that for a very long time. So now, thanks to Laura, I can tell it, and it's true. Amazing. And the paper has a very long name. It's detecting Oxbow code in Erlang code bases with the highest degree of certainty, but it's actually about a tool with a very, very short name. It's called Hank, and you will see that in a moment. First of all, what is Oxbow code? Let me tell you a story with an example so you can see what it is. Let's say we have a large application, but so it fits in the screen. The whole application is this thing. It basically has a run function that evaluates, given a param, it runs the evaluate function and returns something. It prints it out and returns the result. That's it. We did the test-driven development, so we have a test that asserts that when we run with some parameter, it's actually evaluate. There comes our boss, and he asks us to, they want to do some A/B testing, so they want the function to sometimes evaluate and sometimes ignore the parameter. with a certain percent. So we add an environment variable to the application called sample rate. We set it by default at half, like a 0.5. So half the time it will evaluate and half the time it will not. We add a test to prove that if the sample rate is 0, we ignore everything. And if the sample rate is 1, we evaluate everything. The test, of course, fails. So we fix the application, adding the line to get the value from the environment configuration, and a macro with another default value, because application get env with 3 arguments takes a default value, so we use that thing. And with that sample rate, we intermingle another function, so that sometimes the function is evaluated and sometimes it's not. Now the test passed, and we are happy with it. Time passed, some months after that previous ticket, maybe the same developer, maybe some other developer has a ticket that says, okay, we are happy with this, now remove the sampling. So they go back to the code and they find this. And when they have to change this, again, doing test-driven development, they have to make the code run so that it evaluates every time. So they remove the first test for the ignore and remove the sampling from the second one, going back to the original test that says whenever we want to run with some parameter, the thing is evaluated. The tests, of course, fail. And so to fix that, they just need to remove this line. Because if there is no first case in that function, the only clause that is evaluated is the second one, so it's always evaluated, done. But as you can see, and maybe some reviewer can see, there are some leftovers here. So first of all, why do we have a function with 3 arguments and we only use 1? We can remove the first 2. The function is private, so no problem with external uses or whatever. So we can remove these 2. But actually, if we remove these 2 parameters, we can remove the whole thing. Because maybe evaluate with 1 parameter calls evaluate. With 1 parameter, we just don't need maybe evaluate at all. So we can use just evaluate. But in that case, sample rate will be unused. And if sample rate is unused, we can ignore it. But if we ignore it, we can just remove it. But if we remove it, we can just remove the whole function again. And so we can remove the usage of that parameter. But if we remove the usage of that parameter, the compiler will tell us that we have a value assigned to a variable that is not used anywhere, sample rate. So we can remove that thing as well. If we remove that thing as well, the code will compile, the test will pass, and everything will be shiny and beautiful. But still, some keen-eye reviewers may figure out that we do have a macro there that is not used anywhere, this one. So we can remove that macro as well. And even so, we still have some other stuff laying around that we added in the first place and we never remove it. And that stuff is this environment variable, which has a name that somebody who is not the original implementer can't tell for what's the purpose rate. It's a sample rate. So where is it used? Imagine this is a very, very large code base with years of development on it. You have to actually verify that that sample rate is not used anywhere before removing it. It's not simple. Once we clear up all that code, we are back to the original program that we had. And that's great. It's less code. It's easier to maintain. It doesn't have a lot of, for instance, it's not computing a random value in the middle of the program for every execution and whatnot. It's much better. We can all agree on that. But if we agree on that, then why do developers don't clean up all those things when they need to do the removal of the sampling, for instance? Well, the thing is, let's say, why don't we remove this macro? Well, this module is small, and this macro is in the module. But if the macro is defined in a header file, the developer, before removing it, has to be very, very sure that it's not used anywhere else. And if this is part of an umbrella project, it has to be sure that it's not used in any project where the library is shared. It's easier not to remove the macro just in case. Or is this value not checked anywhere? Can we remove sample rate from the configuration? Well, maybe, but we can check if it's used in any application get_env call anywhere. But that's not enough, right? We can use application get all env and use sample rate somewhere and break the code by just removing a parameter. It's not simple. And these arguments are easy to spot that they are not used. But then again, that function may be a callback. That function may be called dynamically from somewhere and used as a parameter on somewhere else. And so you are never sure, and it's far easier for a developer, particularly somebody who's new to the code, to keep those things there just in case. And the whole point of this is that whoever is working on this, they don't know if this is removable. And if they don't know, they tend to keep it. And that code that stays there, even if it's not used, if it's not needed, or even compiled anymore, is what it's called Oxbow code. Later in the lunch, you can ask me the story of why it's called Oxbow code, and I will be very, very happy to explain. It's a funny one, so if you want to know, just let me know, and I will tell you. But the important part of this is that myself, as a developer, I wanted to be sure and to be able to clean those things up in my code bases, and I want other people to be able to do the same. So in Nextroll, the company I work for, we have twice a year, a week to work on whatever we want. And that week, last week of last year, we decided to work on Hank, from Hank Scorpio from The Simpsons. And Hank is a River 3 plugin that detects Oxbow code instances in your code. It is extensible. We have identified a couple of different instances of Oxbow code that we know of, but if you know more, you can add more rules to the system and detect even more Oxbow code in your code. It's accurate, and I will talk about it in a little bit, but Kosti's keynote was a great introduction to this. Hank has the same goal with the same purpose and the same motivation to be perfectly accurate and report no false positives. And it's configurable. So if you don't abide by all the rules, you can remove those and ignore those particular instances. I will tell you how in a moment. So basically, what can Hank do for you? If you run River 3 Hank on your project, it will tell you if you have unused record fields. So for instance, in this case, you have a record with 2 fields, but you are actually only using one of them. So Hank will tell you that your records are too long. They have too many fields, and you can actually remove those fields since you don't need them. It will also detect unused macros, like the one I showed you in the example before. It will detect unused header files that you have in your projects, and they are not included in any file in them, so you don't actually need them. It detects unused configuration options, like the one I showed you before, sample rate. Unnecessary function arguments, like, again, those that I showed you before. This one is a very particularly tricky rule because it has to avoid emitting warnings for stuff like callbacks, NIF function, NIF stubs, dynamically called functions, and so on, many other things. But basically, with all those exceptions, it will find functions in your code where you have arguments that are ignored in every one of the function clauses. So you can remove them and remove them from your function calls. It detects unused callbacks. This rule is very opinionated. It assumes that when you define a new behavior in a module and you add the callback attributes, you will use those functions for dynamic calls in that same module. If you abide by that rule, and you should, but if you abide by that rule, this rule of Hank will tell you when you have extra callbacks that you don't really need. And someday I will fit an example here, but my PowerPoint skills are not that good. But you can understand basically what this thing is. It checks header files, and if you are including them in just one module, it will tell you that you can just paste the code there instead of using a header file. And the same with attributes. If you have a macro defined in one header file, but you're only using that macro in one module, it will tell you that you can just define the macro in that module instead of a header file. And you can add your own rules. To create your own rules, what you need to do is implement the Hank rule behavior. It just has two functions. The first one receives an AST and the context. Ask me in the launch about the context, and I will tell you. But it basically returns a list of properly identified Oxbow code instances. And then you have an ignore function that gives you a pattern, and it matches against the identifier for the Oxbow code instance. So you can, through rebar config, you can specify what particular Oxbow code instances you don't want to emit a warning for, and they will be just ignored. It's not trivial because you need to manage properly. You need to manage the AST properly, but by basing your rule in already existing rules, it's not that complicated to implement new ones. And the most important part of all, and what comes from Kosti's talk, is that Hank is accurate. As Kosti said, the Dialyzer is never wrong. It may not report all the discrepancies, but whenever the Dialyzer said there is a problem there, there is a problem there, that's for sure. And so when we created Hank, we decided that our goal was for Hank to be never wrong. And you may, some Oxbow code instances may slip because Hank is not able to find them, or it's not sure if they are actually unused. But if Hank says that certain piece in your code is unused, you can be sure that it is unused. And with that in mind, we did two things. First, we added a proper list of assumptions to each rule so that, for instance, with the unused callbacks, the rule itself states that it only works if you follow the rule to use the callbacks in the same place where you define them, in the same module where you define them. Otherwise, it won't detect anything. And on the other hand, we restricted the rules to the extent where Hank can be sure about the code not being used. For instance, when you have a module that defines, that implements a behavior, and that behavior may have undeclared callbacks, like, for instance, genStatem, where each state is a callback and the name of the function is whatever you want, Hank will only check exported function, not exported functions, sorry, because those are certainly not callbacks for unused parameters. But it will leave the unused parameters in every exported function alone, just in case they are actually a callback for genStatem or whatever your behavior is. We are working with the OTP team to improve that detection a little bit, but still we always fail we always go for the no false positive side in the implementation of every rule. So we tried it. We created a tool, we wrote it, and we actually published it on XPM. It's an available plugin that you can download. And we tried it on some repositories, and these are the results that we found. Again, if you want me to tell you how we tried this on these repositories, because it's not trivial, again, in the launch, I can explain the process for all of them, which is not the same. It's different in any case, in every case. But basically, we tried with the Erlang OTP source, the oldest and largest source for Erlang code base. And we found a lot of things. Be careful with these results. We ran Hank on the tool, and we just counted the results. We didn't analyze the super properly, the accuracy of everything. But in any case, there are more than 1,000 macros that in OTP that are not used. Most of them in WX Erlang, but still. There are many unused record fields and function arguments, and there is even one configuration in a config file that is not used anywhere in OTP. We also tried with a very large project, which is Kazoo from the people of 2600 Hertz. It's a very, very large code source that I always use to test my River 3 plugins, like the Formatter or Airbis or whatever. And so we tried Hank, and we found not that many Oxbow code instances, but some, like 150 unused macros, and some unused record fields, etc., header files, configuration options, etc. And we also tried on a code source that I was a developer of back then when I worked at Erlang Solutions, which is Mongoose IM, and I know for certain that it is very carefully maintained. And even in that code base, we still find unused macros, record fields, and function arguments. So is this tool useful? I think it is. You should try it for yourself on your own project. Since it's open source, you can verify it. And this is we are on version, I think, 1.1.5 or something like that. So it's very young. It's a recently created project. So there are many things to do. For instance, when I published it on Slack, on the Erlanger Slack, one of the first questions was, hey, can we use this for Elixir? And the answer is, of course not, because it's macros. It detects Erlang macros, which are not present in Elixir, and many other things. But whoever is willing, you can create your own Hank for Elixir. I'm pretty sure that it can serve as an inspiration, and also you can use some of the ideas behind it to write the Elixir version of it. Of course, we detected a couple of ways to find Oxbow code, but we are very far from completeness on that regard. So whenever you come up with new stuff that is Erlang code that is unused, we can add more rules. You can create your own if it is super particular to your project, but if you want to contribute, you can add more rules to the actual Hank project on GitHub. And it needs improvement. There is a whole conversation about parsing and the OTP tools for parsing code that I've been having since I wrote the River 3 formatter. It's super, it's complicated, I will say. The tools don't make the life of their users easy. So if you want to help with that, that will be super appreciated. The algorithms for Hank are pretty much optimized already, but they can be used. They can use some more optimizations, particularly in those that have to traverse the code multiple times to find if a particular thing is used and how it is used and whatnot. And of course, there are always false positives that escape our our imagination, particularly with macros. And if you don't know already, I hate macros. They are my worst enemy in the whole world. But if you find some of them, I will be pretty happy to accept contributions and requests for adjusting the rules and the code to improve our no false positives rule. Finally, what did we achieve with all this? We created a River3 plugin, which is a static analyzer for Erlang code. It works on source code, of course, because macros. And it detects and reports instances of Oxbow code and intentionally has no false positives. So thank you very much. And if you want to kill some dev code on your way home, you will help me a lot.
Thank you very much, Bruno. This was very inspiring, and I'm looking forward to kill some code in my code base. Any questions?
I think there is one in the what type of somebody. Oh, you.
Yeah,
yeah, it was Annette herself.
What type of AST I am using?
Yeah, so using the normal AST representing the
we are using a modified version of what epp.share returns.
Mm-hmm.
So it's like source code parsing, but the macros are actually variables or atoms or function calls depending on their format.
Mm-hmm. Okay, I see. Do you need any compiler information, so some form of partial evaluation or so to find more things, or would this be future work?
So far, we didn't need, no.
Mm-hmm. Cool.
The only thing we needed, and it's what's in the context, is, for instance, if you're in an umbrella project, the list of applications. Mm-hmm. Stuff like that, where to find the rest of the source code, but that's it.
Yeah. Cool. So Pablo has one.
This is a very good one from Pablo.
The answer is yes, from day 0.
And did you find anything?
No, because that's the thing. Since we used it since the very first day, no pull request passed, or no pull request was merged with that code.
I see. Oh, great. Okay. Other questions? Maybe one final one while Nitin prepares. From your experience, how does it relate to other checkers like Dialyzer, which also helps to find, unused variables, etc.?
Laura, do you want to take that one?
Come again, please.
So how would it relate to other tools? Like, I mean, Dialyzer has sometimes code that it marks as not used and so on, and the compiler itself too. So is it just putting things on top, or would there be some duplication with these checkers?
I think the easy answer here is that they do detect the same thing, but coming from different places or doing different things. As Brujo also mentioned earlier, to find something that you can improve, you can do it from in different ways. So yes, the compiler will detect some things, and the Dialyzer will also complain about some of those same things, but coming from a different place, and so will hang. I think the great thing is, as Brujo was saying, if you incorporate a tool like this in your toolchain, in your way of working, it will always, first, this one has been designed so that it's easier. So again, linking to what Costas was saying, it has to fit well in a developer's way of working and not get in the middle, so that people will adopt it and not drop it after a few days, and it has to be something that you see useful. And I think this tool matches all those checkboxes.
Mm-hmm. So one very short final question: do you plan to develop a Hank plugin for Rebus 3? I think that's what you did, right?
Exactly what I did. Yeah.
Yeah. So there is a Rebus 3 plugin. Cool.
Yeah. Also from the get-go. So first we created a plugin that did nothing, and then we made it detect the multiple code.
Wonderful. Thank you very much. More questions for you in the launch later.
Okay, don't forget about SpawnFest.
Very good remark. You get some time to present this and at the very end. And with this, to our next speaker, Nitin. Can you start sharing your slides? So Nitin is presenting the results of his master's thesis, where he tackled also the problem of type checking Erlang code.
So is my slides visible?
Yes, works.
Yeah. Hi everyone. Myself is Nitin. I'm a master student at TU Kaiserslautern. Welcome to our presentation on bidirectional typing for Erlang. So this is the outline of the presentation. First, we will discuss about a lack of static type system in Erlang and previous approaches to introduce a static type system for Erlang. And we discuss some example with the already existing type system and an introduction to bidirectional typing, why and what is bidirectional typing, then result and conclusion followed by the future work. First of all, Erlang is a dynamically typed language. So the Erlang programs are not examined by any type checker at compile time. And so it's not possible to find any simple type errors before executing the code. For example, if you have a type mismatch, error, like if you are adding a integer 42 with a string, it will throw a runtime exception, but it won't catch it compile time because of the static type system. So having a static type system will catch all these errors. That's the main motivation or a goal to introduce a static type system in Erlang. So there are few previous attempts. I will discuss the few of them. First one is a type inference system based on subtyping by Marlowe and Wagler. So they were using subtyping because it's allow more flexible programs, and in Erlang it's possible to have terms to belongs to multiple types. So they were using the typing constraints in the form of U is a subtype of V and solving that to infer the type. So the problem with their system was this was it was slow, and infer types are complex and did not cover concurrency. And there is an example of an AND function which infer type is inferring a wrong type. In the second parameter, its type is inferred as false instead of a Boolean. So this was not adopted by the it was not adopted or by the Erlang community. The second one is a dialyzer, a discrepancy analyzer, which was in the previous talk, it was well talked about the dialyzer and its history and how it works. So it's based on the success typing, and this type system does not produce any false positive. That was one of the main and strict goal of the dialyzer. So the program assumes it's well typed unless it can prove otherwise. So it has a great faith in the programmer. So it's assumed the programmer is always right unless it can prove. So because of it's easy to integrate into existing code base, because it doesn't need any code modification or anything. It was most adopted by the Erlang community, and it's part of the Erlang distribution now. So so here is an example of how a length function which accepts a string a list and a integer then return the length of that list. So when the dialyzer infer the success type of this, it was returning any. It was already discussed by the keynote. So if you are coming from a Haskell or Hindley-Milner type system, this infer type doesn't it's a counterintuitive to the people coming from the strict type system. And another thing is like Erlang type checker by Nachi and John Hughes. It was based on Hindley-Milner type system. They used overloaded data constructor to solve the issue of like Erlang terms can belongs to multiple types. They did a prototype, and they have a like faster type checking with the comprehensible type signature and type errors. And at the end, like they had a like statically typed subset of Erlang, which is quite similar to Haskell. One of the problem with that approach was like already existing code. For example, it's returning some union type or something. You have to add an algebraic data type and modify the code based on that to make it a type check based on like a Hindley-Milner type system. So, before that, I want to discuss some of the like dynamic type behaviors in Erlang, which makes it like quite difficult to introduce a static type system. For example, list tuple, which the output type of this function depends on the number of elements and the type of the elements in the list. So the output type is kind of dependent on the parameter value and types. So same with the element which return the position of the tuple. It's also like the output type depends on the argument value. So like maybe like we need like a complex type system like dependent types or something to solve this kind of dynamic type behaviors in Erlang. So like next, like we will discuss some of the examples where like comparing with dialyzer and etc. For example, here is a lookup function which take a key and a list of tuple of key value pairs, and if the key is present, it will return the value. Otherwise, it will return none. So basically, if you run the dialyzer on this code, it won't it won't catch the type mismatch error here. Like this lookup return function at the line 7 will return 1, but and it's matching with the string. But dialyzer could not catch this because if you see the infer type, it's actually returning any, and matching any with the string is like a valid thing. So this won't give any error or warning by dialyzer, but at the runtime this will crash or throw an like runtime exception. So like how the ETC tried to solve this is like they are introducing an algebraic data type, maybe with the constructors none and okay, and if you modify the code to return based on that thing, based on the constructors of the algebraic data type, maybe the function of the lookup will inferred as a like it will return the type of maybe. And so it will return, so in the line 7, so if you match, so it will return okay and 1, and if it will match the type signature and it's not matching, and it will throw an error, and it will find the ETC can find this type error with a little bit code modification by introducing an algebraic data type. Another thing is like a polymorphism, like this is a simple polymorphic function like which accepts a function from A to B, type of A to B, and a list of type A, and apply that function on each element of the list and return a list of type B. So in the line 6, we are applying a like a Boolean function of a list of integer, but dialyzer could not catch this because when the dialyzer infer the polymorphic relation, it's not adding that like type variable relation. It cannot properly infer that, and it's like accepting any function and a list of any and returning list of any. So it will not throw error or warning for this line number 6. But if you run if you run this will catch it. This will throw a runtime exception. Even though if we provide the type specification to help the dialyzer, it will not, because from my understanding is like it's not keeping that type related relations like that. Okay, it's function of type A and a type from A to B, and it's accepting a type list of type A. Those relations are missed when the type signature is like interpreted by the dialyzer. Another thing is like higher rank polymorphism. Erlang allows higher rank polymorphism where like polymorphic types occur at anywhere in the type signature. So for example, here is like a simple example. We are passing an identity function, and we are calling that ID function like on an integer and a Boolean. And so if you use a Erlang type checker, which is based on Hindley-Milner type system, so it cannot handle like a higher rank polymorphism. So it will throw error, but even though it's a valid type, it's even the valid program. Even dialyzer could not catch this, could not properly infer the type of higher rank polymorphism. It will also like accept a accept a function from any to any and return return a tuple of any. So both dialyzer and ETC have that problem of undecidability of higher rank polymorphism. No, it's a non-issue. So that's how why we are introducing like a bidirectional typing, which combines both elements, like both modes of typing, type checking and type inference. In type checking, we are taking an expression and type as an input, and we will verify that expression as that given type. In type inference, we infer that we take an expression as input and infer the type and give it as an output. So we are combining these benefits of properties of both type checking and type inference in bidirectional typing. So the advantage of this thing, bidirectional typing, is it can support higher programming features such as like higher rank polymorphism, subtyping, or even dependent types. It's syntax directed, and we need only like top level type annotations, which is already supported by type specification in Erlang. It can be also used in the type system where annotation-free inference is undecidable, which I mentioned earlier, like the higher rank polymorphism, complete inference is like undecidable. So we can use that in that case also. Here is like just introduction, like basic examples to how the bidirectional type judgment looks. As I said, there are like two, like the red arrow for type checking and the green arrow for type inference. So here is like a simple type inference where like if the variable x has a type already in the context A, then we will infer the type and return the type as A. Another one is like a lambda abstraction. So here like we are checking that particular lambda abstraction has a type from A to B. So function type A to B. So we know that okay, the lambda expression argument x has the type A. In that case, if we can verify that okay, the lambda abstraction body E has the type B, then the the lambda expression has the type of the function A to B. So how in like Hindley-Milner type system they use like they infer, so they will have like they will have a type variable like a placeholder for the argument x. Then when more information comes, they will unify and then fix that, like then find the corresponding type for that argument x. So that's like something different from how bidirectional typing is. Another thing is like an application judgment, where it's used both like a type inference and a type checking. So if we want to check like an expression E1 is applied to E2, we infer the type of E1 as an A to B, a type function type A to B. Then we will ensure that the argument E2 has the type A. Then the whole application E1 applied to E2 has the type B. Here is an example of we are using both inference and type checking in single judgment. Otherwise, like subsumption rule, where like if you want to check whether an expression E has a type P, we can infer the type type of E as an A. Then we can verify okay, A is in like a subtype of B. So it's used for like a placeholder for checking everything. We just infer and we will verify okay, it's a subtype of the given type. So basically, we were able to like build a prototype based on this thing. So so this bidirectional typing subsume the Hindley-Milner type inference, and it's also like support union types with union types higher rank polymorphism with only like top level type annotations. So like with our prototype implementation, we were able to run it on like three small modules in the OTP. And we want to show that, we want to say that, okay, we were able to type check everything with only like, we needed to add like a 7 type annotation or type specification. We didn't modify any user code or anything. We just added the type specification when the function, some private function was returning some union type. I will show that example. So this is just a comparison with the time with the ETC, where like it's like almost same performance with the ETC. So here is an example. Okay, so this is this find function from ordered dictionary module. So here, like, so this function was returning a like a union type of atom error as well as the tuple OK value. So in case of ETC, we have to introduce an algebraic data type, but we were using already existing this type specification, and we are using that to type check the find function without any modification or anything to this. Another example is like delete with friend. This was like a private function in the queue module, which were returning like a union type of Boolean and list. So we added this type signature, and with this adding this type signature, we were able to type check whether this function has like the proper type signature as we provided. So similar to this, like we added only like we used like added 7 type specification total for all those code. So still the limitations are like, as I mentioned, like the dynamic type behaviors previously discussed or still not able to type check yet. We may need like some complex types like dependent types for those cases. So like our future plan is like, so it's now like to like very subset of Erlang. We want to extend it to the whole Erlang syntax, including the records and subtyping, inbuilt subtyping relations, such as like positive integer is a subtype of like integer. All those things we have to add those rules. Another thing is like partial evaluation, which is like implemented in ETC by Japan and John Hughes, which were used to like type check the dynamic behaviors. If you have the information available at static time, we can partially evaluate and use that to reduce the code and type check from that. Another thing is like concurrency and message passing, which is not type checked yet. One more thing is like type checking legacy code. Right now, like if we have like some module which we cannot add any type specification or something, something like we can add an external file which like with the corresponding module and all the type signature, so which can use that external module with the only the type specification, actually not modifying the old legacy code or something we are thinking we have to implement. So in summary, like so we used like the bidirectional typing with both the benefits of the type checking and the type inference. So type checking is used to like the type check the like the features like which is undecidable to infer, and the type inference is used to avoid like a lot of like annotating each code which can be like inferred. So we are balancing both the type checking and type inference by taking the good properties of both. So with bidirectional, it's decidable for any advanced expressive type systems. And it's also here like we are the type checking its sound without much limiting to the philosophy or like the programming style of Erlang. And much more details like the how the type rules are for the like the type rules and type judgment based on like the bidirectional typings are in the paper, and how the bidirectional typing with the polymorphism works. All those things are more added into the paper. You can check it out there. That's it. Any questions?
Thank you, Nitin, for the presentation. Questions? We have one raised hand by Costas. How does this work now? Like this. yeah, should be able to talk now, Kostas.
Thanks for the talk. So I'm a bit confused about the word top level versus. If I understand correctly, to me, top level functions are those that are exported.
No, like I mean, top level means like even if it's a private function which is not exported, we like if it's using, for example, higher rank polymorphism or something, we have to add a type specification on top of that.
Can you explain to me the terminology top level? What is not top level?
Means in example, for example, in C++, we have like a function takes and we add a type like X is a type of integer. But in Erlang, we can like a type foo, like in the top level only we are adding the type specification, different from C++ or Java, where like when we declare a variable, we add a type annotation there.
So not for locally defined functions.
But a private function to a module is locally defined. I mean, there is no other way to define. How do you define functions other than, Anyway, perhaps a detail. In your example, you added some specification for a private function.
Yeah.
So if you go back to the slide. But I'm a bit confused because this function does not return Boolean. It only returns false.
So that like so that's the limitation. So like we are like considering false as a Boolean, so not separating as a false, or like we are not using the I know like the Erlang's type specification is like too specific and too complex, but currently our prototype does not handle that specific, so it consider false or true as a like Boolean type.
I'm confused. False is an atom. False is just an atom.
Yeah, but how our prototype designed is such a way that atom false is considered as a Boolean type. So it's a special case for
false is a Boolean type. I'm not saying that. The problem is that there is another Boolean type, true, and this function will never return true.
Yes, so this is like the limitation of our implementation. We implemented such a that if we see any false or true, we will just assume that's returning a Boolean type. So we are like not going to specific, we are doing a generic level.
Yes, the problem with that is that now if you match this delete with front with true, this is something that will crash and you will not detect it.
Yes. So that's like that's just I would say like limitations of like that's how we decided to implement. If we can like add an atom and consider each atom as like its own type, that can be possible. But because of like it's like a prototype, which we decided to go with this. I totally agree with you. It won't catch when it's matching with the true.
So that brings the question, and sorry to hijack this. So what do you guarantee? Are you going to catch all the errors that are type errors or not?
So if I implement properly, I will be able to, but right now, I haven't, these things are not handled with our prototype implementation.
Okay, thanks.
So there is another question by Alan Jeffrey. I'm inviting on stage. Hope it works. Hi, Alan.
So this is really interesting work. so this is very related to stuff we've been looking at inside Roblox about how do you add type inference into systems where you're expecting to have minimal amounts of false positives. Am I correct in thinking that you're requiring all exported functions from a module to actually have a type specification?
No, like as I mentioned, like so type specification is used to help the type inference. For example, in the Hindley-Miller type system, they are not using any type specification, or even dialyzer use it as a contract. It won't use it to inference, help the inference. For example, that higher rank polymorphism, which we need some type specification to help the inference, because otherwise it's undecidable. So
in which case, are you doing whole program analysis, or is it per module analysis?
I would say like per function.
Oh no! I mean, in the case where the caller of a function and the declaration of the function, if the function's not been declared with an explicit type, then the call sites influence the inferred type?
No. So we are using that like that graph by which function is calling first, then infer the type of that first. We are that.
Okay. So the inferred type is just given by the declaration site, not by the call sites.
Yeah.
Right. Okay. Yeah. That makes sense. Cool. Yeah. It's nice work.
Thanks, Alan. Any more questions? I hope I did not skip anything. If this is not a case, thank you again, Nitin, for your presentation. We will take further questions in the launch afterwards. And now it's time for the two lightning talks assigned to that session. The first one will be by Adolfo Neto. Will join us here on stage in a second. And he will present about his experiences about teaching Erlang and Elixir on YouTube and how to gain more Erlang programmers and Elixir programmers in our community.
Okay, thank you very much for this opportunity. Is my sound okay? Can you see my screen?
All good, perfect.
Okay, so I'm going to talk about my experience teaching Erlang and Elixir on YouTube. My name is Adolfo Neto. I'm an associate professor at the Federal University of Technology, Paraná. And these slides and a little bit more are here on this link. I typed this link on the chat. And so I have two channels. This one is only in English and only about Elixir, Erlang, and the Bean. And this one is in Portuguese, and I do several other things also here. And my focus in my videos that are about Elixir and Erlang is more on beginners than on experienced developers. So that's my point of view. And these are my numbers, very small numbers for this year. Some Elixir videos in Portuguese. I have 16 videos in total. 1,100 are about to 1,200 views, and Erlang videos in Portuguese 15. And there's one in which I have. It was not a good idea, but I did Elixir and Erlang, and some videos in English. And there are two talks, one from Laura and one from Simon Thompson, that they gave to my students here at the university. And the types of videos that I do, it's more, there is one Learn You Some Erlang series where I'm reading, I'm covering Fred Ebert's book. Why did I shoot Fred Ebert's book? Because it's a free book. And sometimes I read a comment, a blog post, or Elixir school page, or I solve an exercise from Exercism, Advent of Code. But of course, there are other channels around, and there is this one called Erlang Tutorial. And also there are some old videos, for instance, Basic Erlang 1 by Simon Thompson. And also this one is interesting because it seems more focused on advanced programmers, or at least intermediate programmers, because it's for people that want to create a cryptocurrency trading bot. I don't see a beginner, oh, I want to create a cryptocurrency trading bot. So, but you see that it's very popular, more than 5,000 views, and it's from last year. But of course, there are some questions like, is Elixir a good language for beginners in programmer? Is Erlang a good language for beginners? And I know there are already a lot of resources for more experienced programmers, great books, and of course, it's easier to focus on more experienced programmers because those, if they work with another language, they can pay with money or time to learn Elixir and Erlang. And maybe the best things that you have in the bin are only understandable by more advanced programmers. So of course, if you want to create Elixir Erlang videos for beginners, there are some basic generic ideas that are valid for any YouTube video. But the goal of this lightning talk, is to get idea that maybe are not useful not only for me, but for other people, maybe that can also create their own videos. And I want to get input from you, how to bring more beginners to our Bean community. Maybe with creative coding, maybe for instance, there is a great Groxio series of videos about Tetris in Elixir, but how to reach more people, how to be more effective when producing videos. So that was the goal of this talk. If you want to contribute ideas, you can talk now, or there in this link, which I put on the chat, you can also write your ideas. Thank you very much.
Thank you for this overview. Have you a few questions? One by Brujo. How comfortable are you with YouTube's algorithm and the rule that imposes to content creators?
Well, I'm a professor. I have my salary, so I don't care much about the YouTube algorithm. I like that sometimes some people that I don't know say, oh, I have watched your video about Erlang. I already know Elixir and I'm studying Erlang now because of your video. That's my simple answer. I don't care. Right now, I just like that YouTube is a place where I can upload my video and it's free.
And I think that's a great service to the community. Thank you very much. And another question by Laura. As a non-English native, I too have a recurrent doubt about creating content in languages other than English. Given that you do both, what are your thoughts on this?
Okay, yes, that's for me. Of course, it's much easier to create videos in Portuguese, and I force myself to also create videos in English in order to practice my English, which is not perfect, far from that. And I see that there is some space here in Brazil. Brazil is a large country with a very big population, and there are some very popular YouTubers that they produce content in Portuguese, and it's about software development. Of course, there are other YouTubers, but some YouTubers, they produce content about software development, and they have a very large audience. So I think it's possible.
Yes.
I'm not sure I have answered Laura Castro's question, but
I think that's a common problem all of us non-natives kind of share, that I felt very uncomfortable when I had to start recording all my lecture videos for lectures under Corona, so I can totally understand that it can be a bit intimidating to put it so public, but I think your English is very understandable and pretty well. So I hope that even beyond the Brazilian and Portuguese community, people will be able to benefit from the material. And then probably a final question from Fred that is related to which programming style should come first. Do you find it easier to teach programming to people whose mind have not been polluted by imperative programming?
Yes, that's a good question for which I don't have an answer, because all my students, when they arrive to me, they already know some other language, maybe 1 year, 2 years, because I teach Introduction to Functional Programming, which is an optative. It's not mandatory, so I really don't know. I would like to have the opportunity to go to the first year students and teach them Elixir or Erlang, but right now I can't do that.
Yeah, so from our experience too, we started here now teaching functional programming in the first term, and if people need to unlearn, it's sometimes very painful. It doesn't hold for everybody. Some students are just very good in understanding the right abstractions, but unlearning is definitely a thing, right?
That's
and then
another.
yeah, and then Fuho, finally, how do you measure success? So how do you know if people actually learn something from your video? I think that's a very difficult question, because measuring the effectiveness of teaching is, I think, or would assume, from my knowledge, still a pretty open problem, right?
Yes, I really don't know, because I know that people watch because I see the numbers, but maybe they didn't watch really. They just let it play and they didn't pay attention. So it's impossible. I'm also a podcaster. We have a podcast in Portuguese about Elixir called Elixir in Foco. And also it's the same thing. I only see, there is 100 plays, 200 plays, but I can't tell you that people really listen to, unless they have some question that it's relevant to the content, which occurs once in a while, but it's far from frequent.
Mm-hmm. So Laura was asking, what about comments? Do you get a lot of comments back on the videos?
No, not a lot of comments, and once in a while there is a comment in a video, or because we also, the Brazilian community is very active on Telegram. We have at least 2 Telegram groups for Brazilian Elixir, and at three for Brazilian Elixir and Erlang developers. So there sometimes I get some comment, this was nice, but nothing that I could say. For instance, I could answer Brujo that, this is people actually learn from my videos. I can't tell that right now.
Mm-hmm. There's one more suggestion regarding how to make them better findable and searchable on YouTube, but we'll move that one to the break and continue with the next lightning talk. Thank you, Adolfo, for these insights.
Thank you,
your
Annette.
engagement in the community. Thumbs up for you. Okay, and with 36 minutes till we resume back here. You will be notified if you assign to the session. Then you will get a ping once we are back standing here. And I hope to see you now for some discussions. Take care.
So Bastian and I should remove ourselves now, no? Or
yes, I can. You can step off the stage if you can do it yourselves, and I will put you back on in a moment.
Okay.
Before when your time comes.
So how do I get off the stage?
Let me help you. And he's gone.
Okay, I have the video located, so you do the introduction and also video.
Perfect. Okay. And I see that people are slowly flowing into the room, is what one would say if it was a room. Apparently, it's just little boxes in a list, most of them without even a photo. I will remind everybody that I cannot put a photo on, and this annoys me very much. Helps a lot to locate people that you know. Does not help at all to locate people that you don't know, but oh well. Welcome to this final session of the Erlang workshop at ICFP 2021. We have one final session with 2 paper presentations and 2 lightning talks. And we are ready to get on with the first one. The first presentation will be by Victoria Ferdos, who has been researching and writing about security in Beam-based systems and Erlang systems during the last few years. And this year she's presenting a paper titled "What are the critical security flaws in my system?" Victoria is with us and is connected by audio because of a bit of a flaky connection, but we have a video of yours, and we will start with that.
My name is Victoria Ferdes. I work at Cisco on a product called Cisco NSO. Today I'm going to present you my latest work, which is in scope of software security. Software security is a critical topic. As we see, the threat level is increasing. Cisco published an annual cybersecurity report where they showed that the total volume of cybercrime events has increased almost 4-fold in nearly 2 years. And the FBI published recently yet another report where they showed that there was an increase of more than 300,000 complaints of suspected internet crime from 2019 to 2020, which means that the threat level keeps on increasing. And therefore, one may say that programmers must have a security-aware mindset, and they must ensure that they deliver secure software. Well, it is easier said than done. The area has received great interest in the last years. Methods and tools have been developed. Take an example of the Cisco Secure Development Lifecycle. It is a software development methodology that underlines security at every stage of the project. It starts from day 0 when you're even only thinking about the project. And of course, there are tools. One example are the security checkers. Security checkers are tools that use static analysis to identify security vulnerabilities. For instance, remote code execution, buffer overflow. Security checkers can start from a point where a non-trustworthy input enters the system. And then they are going to follow the data and report if the data is manipulated by the program in a way that can be exploited by the attackers. There are security checkers for Erlang as well. There is PEST, which is the oldest and reports a lot of false positives as it doesn't use data flow analysis. There is a trust zone analyzer and another security checker built into Refactor. Both of them are based on data flow analysis. So there are even tools for Erlang, so we could say that there are methods and tools to help the programmers. However, there is a catch. Brittany and her colleagues published a survey in 2013 where they point out that developers are not using security checkers. One of the biggest reasons are because of the existence of the false positives. And, well, if you think about it, this is understandable. Just imagine you have a project containing millions of lines of code. The security checker returns, let's say, 100 results. You sit down, you start analyzing the results, and you become disappointed. None of the results are valuable or relevant. They are mostly false positives. So you feel it is a waste of your time and you stop analyzing the results. You stop using the tool. I consider this as a problem and I would like to make the situation better. I observed that there is no Erlang specific security checker that underlines the most critical vulnerabilities. And I wanted to fix that. So my goal is to provide a security checker that shows the most critical vulnerabilities first, so the programmers don't get disappointed. Let's talk about security flows a bit. In real-life projects, modules belong to multiple logical groups. A group of modules solving a specific problem using the same privilege level can be considered as a trust zone. These modules can interact with each other freely, they can trust each other and the other's data. In real life, we are not going to validate data in every module, right? So modules belonging to one trust zone, they trust each other and the other's data, therefore there is no need for data control. However, data that is entering the zone should not be trusted and needs to be validated. Hence, our focus is on the boundaries where the system is most vulnerable. And what is the goal? To validate or sanitize data entering the zone. We want to avoid situations where data entering a trust zone through one of its entry points and flowing into a high-risk vulnerability without any sanitization. Now let me give you a longer example. So let's say we have a component in our system that is responsible for user handling. And whenever a user arrives, it is going to perform some initialization. As part of the initialization process, the component is going to load the user cache to memory, ensure that the workspace of the user on the file system is present, and starts user processes. And the ensure user dir function is implemented as follows. Take the username given as input and ensure that the directory named after the user exists in the root directory. We know how to do this in Unix, and of course we know about OS command. So the implementation of this function becomes calling OS command with a prepared string. If the user is the wiki string, this works as expected. If the user is a hello atom, then well, it's going to crash. Fine. But if the user is the following string, semicolon rm-rf/, then something terrible is going to happen. So what's going to happen is that we are going to execute a command that attempts to delete the whole root directory. So we have discussed a bit the security flows that are in focus right now for the paper, but the next question is, what makes a security flow critical? The example I gave you is a critical vulnerability. However, the altered code I show on the right side of the slide would be considered by a programmer not critical or false positive. Why? As you can see there, we first check if the user exists. So there is some sanitization, validation of the incoming data. And only if that user exists, then we are going to continue with initialization. In summary, we can say that criticality depends on whether there is input validation or sanitization of the incoming data. Alright, so to prioritize vulnerabilities, we need to be able to recognize input validation in Erlang. How can we do that? There is a language construct in Erlang called patterns that allows us to test the structure of a given value. Examples are check and the check2 functions. However, notice that check3 is not really a good input validation, right? It uses the Joker pattern and that does not put any constraint on the expression. The second and last language element we have are the guards. Here again, we need to ensure that the test is meaningful. So a guard that is only a type test should not be considered as input validation. Now we know how to recognize input validation in Erlang. So now we can discuss the prioritization problem. So our goal is to prioritize vulnerabilities where an incoming data flows into a vulnerable function of Erlang OTP without any non-trivial input validation or sanitization. If you think about it, those are the most critical ones, because it means that whatever a trust zone is going to receive, it is going to reach the vulnerable function of Erlang OTP. So this gives a possibility to exploit our code by the attackers. In the analysis, we are going to use higher order data flow analysis for multiple reasons, but we are going to use it to see if an incoming data reaches a vulnerable function of Erlang OTP. That's the most important part. And we are going to use control flow analysis to ensure that when the execution passes between the entry point and the vulnerable function of Erlang OTP, there is input validation, and it is towards the entry expression. The algorithm that prioritizes the found vulnerabilities is as follows. We take as input triplets, each of them representing one vulnerability. So in the triplets, we are going to have a source, and that's where the data entered. That's the entry expression. We are going to have the sink, which is the reached vulnerable function of Erlang OTP. And we are also going to get the read set of the source calculated by higher order data flow analysis. The output of the algorithm are the source sink pairs tagged with severity. Okay, the algorithm goes as follows. Now later I will show you examples, but let's go through the algorithm first. So we are going to start from the sink, and we are going to perform a backward search on the execution path provided by the control flow analysis. We need to be careful with branchings because we need to explore all possible execution paths. Now, to narrow down the problem space, we are going to use the data flows read set to prune the execution paths, skipping the part which is independent from a source. So, for instance, if in the execution path there is a function invocation where we do not pass the value of the entry expression, that function we are not going to explore. There is no need for that. All right. Now, at every step of the walk, we are working with one Erlang expression from the execution path. And what we are going to do with that Erlang expression is that we are going to check if it is a relevant, non-trivial input validation. So it is relevant if the input validation is against the entry expression. So if we find an input validation that is against some other value, then well, our entry expression has still not been validated. Then we need to see that the input validation is meaningful from a security point of view. So if it is a pattern, but it is the Joker pattern, then we are not going to consider it as input validation, and the same holds for type tests guards as well. All right, so if we do this check on every Erlang expression that is in the relevant part of the execution path, and we walk backwards on the execution path. And if we reach the source in any of the execution paths without finding relevant input validation, then we have found a critical vulnerability, because then we discovered an execution path where the incoming data flows into the vulnerable function of Erlang OTP without any input validation or sanitization. If we do find relevant, non-trivial input validation on all the execution paths, then we are going to mark it as warning only, the severity. Yeah, observe that we do not drop found vulnerabilities. I'm on the opinion that this is only a heuristic and it may down prioritize vulnerabilities. So what I would like to have is to be sure that the very critical ones are marked with critical, and the very critical ones are the ones where there was absolutely no input validation towards the entry expression, and that the algorithm does. So this way I can be sure that I will put those ones as the first one. And then I will have the programmer engaged, basically. All right, so let me show you how the algorithm works. In this example, A is the entry expression, and the reach vulnerability is OS command. So we start from OS command, and we walk backwards on the execution path. So first we get to the true pattern, and well, we see that this is not against the value of A. So we continue. Now we check the bar B function. However, we see that bar B function does not take the value of A, so it is irrelevant from our point of view, so we can skip that. And then we reach to the head of the F function, where we again don't see any input validation against A. So we can conclude that this example is a critical severity, as we did not find any input validation against A before it reached OS command. Now let's see another example when the severity will be only warning. Again, A holds the value of an entry expression, and we start from OS command. We are going to do again the backward search on the execution path provided by control flow. We check through, it is not against A, we keep going, we don't explore bar, the bar function, as we see based on data flow, that it does not take the value of the entry expression as input. So we keep going on the execution path backward. Again, this true pattern is not against A, and then we are going to reach the foo function, and based on data flow analysis we can see that this invocation of the foo function takes A as input. So we are going to explore the function definition of the foo function. We start from here, we see that there is a false atom. This is not an input validation of A. So we go to the function head, where we find a pattern, and we know based on data flow that this is against A, but it is a joker pattern, so this is not this is a trivial input validation that we don't accept. So we keep going. We find again now a true atom, which is not an input validation against A. So we keep going, and now we find a pattern which is a non-trivial pattern, and it is relevant because based on data flow analysis we know that the value of A is going to reach here. So we conclude that we have found input validation on this execution path. So on this execution path, we have found input validation of A. As this is the only relevant execution path, this is the only one that we are going to explore, and we are going to conclude that that this is only a warning severity. It is a warning severity because the incoming data was first validated before it reached OS command. The prioritization algorithm I've showed you is now part of the trust zone analyzer algorithm. So the extended trust zone analyzer takes as input the trust zone with its entry expression, the sources, and it's going to output the source sync pairs tagged with warning or critical severity. The algorithm has 3 phases. The first phase is the initial analysis, which is purely based on data flow, and it is going to find all possible vulnerabilities. The second phase is the prioritization algorithm I showed you, and the third phase is ordering the results based on severity and presenting it to the programmer. I created a prototype implementation of the extended trust zone analyzer, and it is available on my GitHub. You can download it, try it out, and use it. Today I showed you my latest work that I really hope will be used by the programmers. It underlines critical vulnerabilities where untrusted data reaches a vulnerable function of Erlang OTP without any input validation or sanitization. Early results show that the algorithm works and adds only acceptable overhead. Like I tested it with React Core, that was my trust zone, and it added the prioritization, added around 2% to the runtime. I'm planning to continue its evaluation and want to see how it performs on more test subjects. Thank you for listening.
Here I am. And thank you very much, Victoria, for presenting in this forum. So we have a question from, two questions from Brujo. Let's take the first one of them. What's the story behind the name The Joker pattern?
Very good question. I don't know. I guess it's like like the Joker pattern accepts everything, and then there are card games where you can use the Joker character. That's my guess, but it's a guess.
Okay.
Anyone knows it? Maybe.
Yes. Then, and second question from Brujo is whether there will be a rebar 3 plugin to run this on pull requests.
Oh, interesting ideas. Yes, that's a very good idea. I will see when it will happen, but it's a good idea.
I guess the related question is about the code for this. How is this released?
Yeah,
I'm sure you covered this.
Yeah. No, I did not cover it. So it's built on top of Refactorer, the trust zone analyzer, and it uses the analysis framework of Refactorer. And how you use the tool is that you first need to load all your trust zone together with all its dependencies, the related Erlang OTP as well into Refactorer. And then you can, and after loading the code, then you can start the analysis. So, well, I would imagine that one could put it in a CI/CD pipeline that you would save the database of Refactorer, and then whenever you have a new change, then you would incrementally add only the change files to Refactorer, because that way you would cut the time taken to load the code into Refactorer. and then you could start the analysis.
I see. And Peter is asking of any interesting results that you have found. Yes.
Yeah.
And I invited him on the stage because he had his hand raised. And so.
All right. Right. So I looked into React Core, and there I found a few vulnerabilities where we converted lists into atoms, which, it's like it's going to blow up your atom table if you are not careful. And what was maybe the surprise to me is that there was no input validation on it. Like nothing, literally nothing. So that one could consider it's interesting. Yeah, I mean, yes, this. Let's see what else I will find.
Really, really cool. Thank you very much for the talk and the work.
Yeah, thank you very much.
Someone commented in the chat that this is the year where all the talks are about false positives and how to avoid them. And they're absolutely right in every possible domain.
Exactly. I found it very funny.
Yes. Okay. Thank you very much, Victoria.
Thank you.
Okay.
You should invite Sebastián.
Yes. It just happened to be on the stage already, Peter, and so I should maybe send you down and then invite Sebastián and then invite you as well. Hi, Sebastián. So the last paper of the Erlang workshop before some more lightning talks is by a group from Université Catholique de Louvain. And it is about sensor networks and a framework named Hera,
Yes.
that can perform sensor fusion with Erlang and Grisp in a fault-tolerant way and with some very interesting applications. So I leave the stage to Sebastián. Present.
Thank you. You should be seeing my presentation in full screen.
And we can.
Thank you. Okay, so my name is Sébastien Kelbusch. I'm a master's student, and with Vincent Verpoten and Peter Van Rooij, we work on Hera, a framework for fault-tolerant sensor fusion with Erlang and Grisp on an Internet of Things network. And I would like to thank my professor and supervisor, Peter Van Rooij, for allowing me to present our work. So in this presentation, I will first introduce very quickly the concepts of Internet of Things and sensor fusion. Then I will give some context about traditional Internet of Things architecture and low-cost devices for Internet of Things. Then I will present Hera, its purpose, its sensor fusion engine, its software architecture. After that, I'll briefly talk about fault tolerance and give examples of sensor fusion with Hera. Then we'll conclude and give insights about future work. So for those of you who may be familiar with the concepts of Internet of Things, or IoT in short, I'll simply define it as being the large number of low-power devices located at the edge of the Internet and that communicate wirelessly. Now, sensor fusion is the ability to combine information coming from multiple sensors to get a single view of a situation. So it is more accurate, more reliable, and more informative than if we were to rely on a single sensor. Now for the context. First of all, I would like to stress that currently the Internet of Things is growing faster than the cloud. So this graph shows the market share for microchips in different sectors. And on the horizontal axis, as you can see, there is the growth. And the cloud, called servers here, is growing far the Internet of Things is growing faster than the cloud. So we have 5% versus 13%. So a traditional IoT architecture actually consists of cloud and fog computing. So we have a pyramidal infrastructure with a large number of edge devices at the bottom. We might have intermediate fog nodes for data preprocessing, and then at the top, a few data centers to store data and also perform the heavy computations. And while this infrastructure is good for scalability, it has disadvantages. First, it's a complex infrastructure. Not only do we have to develop the actual Internet of Things application, but we also need to write softwares and maintain the whole infrastructure for the rest of the system. And using the cloud also comes with associated costs and a latency that might be prohibitive for some latency sensitive applications, like for example in manufacturing. And also the edge to cloud connection might be surprisingly unreliable. And our approach to solve this issue simply was to get rid of the cloud and live at the edge. And so Erlang is a very good choice for that because of its support for concurrency, scalability, and fault tolerance. Another side of the story is the low-cost platforms for IoT. So Raspberry Pi and Arduino are two very popular platforms in IoT. And in general, when we work on embedded systems, we are working close to the hardware. It involves reading data sheets and even sometimes soldering. And well, to also develop our software with low-level languages. C, for example, is extremely popular in embedded systems. And it turns out that this close to the hardware situation here is more complex and it is error-prone. And at this point, I'm not even talking about distributed computing and fault tolerance. Now, of course, we could, for example, run Erlang on a Raspberry Pi, but it wouldn't still solve the whole hardware situation with the sensors and how to connect them. So there is another platform, GRISP, which we use. It's a low-cost embedded system that boots directly into an Erlang virtual machine. So with GRISP, we have the full power of Erlang at our disposal. And also, GRISP has PMOD connectors. So PMOD is a standard by Digilent. You have two small examples here. And GRISP also developed drivers for popular PMODs. So GRISP truly is a plug-and-play system. We can just take a sensor, plug it in, and it's ready to use. Yet, GRISP doesn't really address the problem of fault tolerance, and of course, it doesn't have a sensor fusion model for our sensor fusion applications. And that is why we need to develop a sensor fusion framework. So that's Hera. And the purpose of Hera is to provide an efficient and user-friendly framework to enable sensor fusion experimentation by a large public. We want it to be simple. So what does Hera do? Hera provides a sensor fusion engine. Hera takes care of the hardware. That's actually done by GRISP, but GRISP is part of the solution here. And Hera handles failures. So what does the user need to do? Provide the sensor fusion parameters and bootstrap the cluster of nodes. So for the sensor fusion of Hera, we decided to use the Kalman filter. The basic idea of the Kalman filter is to start from an initial estimate of a state. And then we use a physical model to predict the evolution of the state with some uncertainties. Then we compare this prediction with an actual measurement, and we combine them optimally to find the most likeliest state. And the key insight of the Kalman filter is to find the right balance between your noisy sensors and your flawed prediction model. Working with the Kalman filter has several advantages. First, it is a well-established technique in wireless sensor networks. Second, for the physical model, we just need differentiable equations, and that's very convenient because many physical and real systems are differentiable. The Kalman filter also has many variations for optimization. And most importantly, the Kalman filter allows for asynchronous measurements. In other words, we are able to compare the prediction with a measurement as soon as we have the information from a single sensor, and we don't need to wait for all of the sensor to perform a measurement. It has small disadvantages though, which is that defining the physical model is not necessarily trivial, but since there are many examples in the literature, the user should be able to find examples and achieve what he wants. So an overview of the software architecture here is very simple. We have three components. On the left, there is the GRIS Runtime library. It contains a full Erlang OTP and it has drivers for PMod, the PMod modules. On the right here, we have the Hera framework, and in the center, the client application. So in the client application, the user will define two kinds of callback modules for the framework. A sensor interface that simply acts as an interface between the driver and the framework. And also the sensor fusion model, where the user will fetch the data from the local data store. And he will also define the parameters for the Kalman filter and use the libraries of the framework to perform the actual sensor fusion computation. And this approach is very modular because we can easily change the modules and use another one. So if we take a broader view of the system, as you can see, every GRIS board is running the Hera framework. And the data flows from the sensor through the sensor interface. We then forward it to the framework, which will share the data with all the boards via UDP multicast. So they are connected by Wi-Fi. Then we store this data on a local data storage, and from the sensor fusion model, we use this data, perform the computation, and again share the data with the other boards. Now, if we want to visualize the data on a computer, we can just run the Hera framework there, and we fetch the data from there. This example is an application that estimates the orientation of a board. It is in the paper.
Problem. Disconnect.
Yes. Let's give Sebastian a few seconds to
come back,
to reconnect, to be restarted and reconnected. Do you have a separate channel with him just so that he's aware that this has happened? Sometimes systems fail in interesting ways.
No, I don't, but I can send him an email. He was talking so nicely.
Indeed.
He's back. Sebastian, you were disconnected.
Yes, I noticed. Sorry, my browser has crashed.
So yeah,
it's not fault tolerant.
I know it's not running.
Sorry, I will be sharing the screen.
No problem at all.
Yeah, just continue where you left off. Huh?
Okay. Okay, so now the presentation is full screen again. Very sorry for this crash. Okay, so yes, the last thing I had to mention is that, of course, the whole thing is happening in real time. So now for the fault tolerance. So that's just to explain why fault tolerance is important in IoT. First, there are multiple points of failure, right? For example, the grease board could be powered by a battery pack and it could run out of power, or it could be a network issue, or a bug in the software, in the driver, or more likely in the user code. A second consideration is, in our opinion, sensor fusion is hard enough, and the user should not do defensive programming nor error handling. So that's why the framework should handle failures to make things easier for the user. And so how does Hera achieve fault tolerance? Well, first, as I already mentioned, we have an asynchronous model, so we are able to compute without blocking. And so if a sensor dies, it won't affect the system that much, at least. Hera also has a dynamic system, which means nodes and processes can join or leave the system at any time without breaking anything. We are also using supervision tools of Erlang, and we encourage hardware redundancy, that is to have redundant sensors and multiple nodes to compute the same thing. Basically, hardware redundancy is fault tolerance for free, except you have to pay for the hardware. But that's very important. And that's how Hera guarantees to perform sensor fusion as long as one grease board is alive. Now, in the paper, we have proved this fault tolerance by performing fault injection, which consists of disabling parts of the system and observing the reaction. But I won't detail this now. Now, for examples of sensor fusion with Hera, we first have more a demonstrator in the paper, which consists of estimating the position and the velocity of a model train with 3 grease baseboards. And so on the train, we have an accelerometer, a gyroscope, and a magnetometer. And on the floor, we have 2 sonars. And that is almost the entire code that the user needs for this sensor fusion. So the first part here consists of fetching the data from the local data storage. Then we defined the parameters of the Kalman filter in matrix form. And in this case, we also have Jacobians because we are actually using an extended Kalman filter. And finally, we call the Kalman library to perform the sensor fusion computation. So this code is very short. It really is the bare minimum. And so it is very easy for the user to define the model. Another example that we present is an attitude and heading reference system, HRS in short. So we use a gyroscope along with an inertial navigation model to predict the orientation of a device. And we also use an accelerometer and a magnetometer to find a direct cosine matrix, which we use as a measurement in a quaternion-based Kalman filter. And this measurement is important to cancel the drift of the inertial navigation model. And so with this system, we are able to find the orientation of a board in real time, and everything is computed on a single grease board. What's interesting with this example is that it really pushes the grease-based board, the drivers, and Erlang numeric computation capabilities to their limits. And if you're interested, there is a video to see the system live. Now, for the conclusion, we say that Hera gives satisfactory results for simple sensor fusion. And because we make no use of cloud, the IoT projects are simpler, cheaper, and more reliable. Hera offers a high-level approach with a focus on sensor fusion modeling. There is no soldering, and there is no need to read through data sheets, and there is certainly no development with a low-level language. Hera is fault-tolerant, easy to use, low-cost, and open source, which makes it an ideal candidate for education and prototyping. We think that Hera is the best existing Kalman filter-based sensor fusion framework for low-cost prototyping. So future work with Hera first involve performance improvements. So there are the grease 2 board that should be 10 to 20 times faster than the grease baseboard. We are also expecting improvements in the drivers And we are working on a new matrix library that should be 10 to 100 times faster. And the good news is that all of these improvements should be available by the end of the year. Possible experimentation with Hera involves machine learning, for example, motion recognition. We believe machine learning and Kalman filters have a different purpose, but they are complementary. They could be used, for example, one could be the input of the other. So we would also like to attempt controlling physical device, because for now Hera is just performing pure sensor fusion and there is no control. And since it is fault tolerant, it would make sense to experiment on real-world rugged terrains. So given the success we had with Erlang in our little research, we encourage more work in the IoT to be done with Erlang. And I think it's also the good time to thank Pierre Schlesinger, the founder of GRISP, because GRISP is also a very good platform for the IoT with Erlang. You can also find a few links here to Hera and to a demo application. That is the user application where you will find the examples that I just showed. Thank you.
Are there some questions from the audience? So I have, while people are perhaps thinking or typing, I have seen quite a few talks by Pierre and all these settings where he's using Grispon. Where do you see this kind of sensor fusion now being used for somebody who is completely uninitiated with the field? Like, what are the applications of this, like at a more practical level?
I have an application. Sebastian, maybe I can give some.
Oh yes, sure. Yes, go ahead.
So one application is the following: that there exists very small electrical motors that are powerful, used, for example, in electric bikes, and inside a home, they are completely underused. So, for example, you could have a bookcase with a motor and with a Hera framework, and it's extended doing control. So the Kalman can also do control, which can find out where a human being is and follow the human, and it can avoid obstacles. And you do not need AI for this. Okay, sensor fusion. So I believe there's many home applications for this. I'm also going to experiment in, for example, people playing football in a team, and the system could basically keep track of all of them. Now, Hera does not do this at the moment because you need to keep track of more than one person. So far we have an experiment with a system that can track 2 people using 4 sonars. Okay, but the more people you need to track, of course, the more sensors you need. Okay, so I think that in our real world environment, there's many applications for a technology at the level of Hera. Okay.
I think you could add that you also wishes to push experimentation and with Hera for education.
Right, exactly. So this is actually very low cost, easy to use. So this work could not and never have been done on anything else than GRISP with Erlang, because it was done in a limited time. So no way could this have been done on a Raspberry Pi in the 4 months that it was done. It took about 4 or 5 months of work there.
And the education dimension there, I guess, is towards people learning about Kalman filters and
also
learning
IoT.
about
Kalman filters are a basic ingredient for real-world IoT. Like in a house, if you have many sensors in a room, they must do sensor fusion. Okay, sensor fusion is a basic thing, and it's not enough to have sensors. Okay, so Hera lets people experiment with it. It's working. Kalman filter is actually really nice. So I was saying it's turning straw into gold. Okay, it's magic. It's like machine learning. People love it, but Kalman filter is another kind of magic, actually. Right, Sebastian?
Yes.
We're very surprised how good it actually works. Of course, you have to tweak it a little bit, but like all magic, you have to make the right application.
Oh, but again, I guess it's another dimension of the concept of redundancy. The more measurements, the more
Yes.
combination. If you're using a model together with your observations, then you reduce the error.
It's a simple physical model, right, Sebastian? A simple mechanical Newton's laws. And
great. More questions? There is a question posted in the Q&A.
What was the cost of the hardware? Oh, that's a good question. So, so the toy train, we actually got a good one, fairly big. It costed like around, with all the track and everything, it costed around 200 euros, right? The toy train.
Yeah.
Because we got one that was pretty solid, but it's just a regular hobbyist train. The grist boards are not so cheap. They cost between 100 and 200 euros, but it also depends on how many there are. I mean, if they get more popular, the price will go down, because they don't have millions the way Raspberry Pi. So we cannot get the cost down to 50 euros unless we make many, many of them. So Per Stutzinger could say that. But the PMOD sensor modules, they cost around 20 to 30 euros each. Okay. The sonar, the navigation, the whatever. There's all kinds of modules, motor control, the little modules. So for 1,000 euros, you can have a really nice experimentation platform for IoT.
Sounds fantastic. All right. Thank you again for your presentation. And since we have been talking on the stage, because he's the speaker of our next lightning talk. Oops. The interface is a little bit flaky for me. There. And I click the right person.
Okay. So can you hear me?
Yes, we can hear you. Maybe you want to launch your slides as well?
Yes, I'm on it.
While Pierre is getting ready, if anyone in the audience has been inspired, especially today, to talk about something after Pierre's talk, there is still time for a lightning talk. We can have it here on the stage, or we can just go outside in the lounge and hang out and talk about a lot of different things. But if you want to come on the stage after Pierre, please message me on the side and I will arrange it. So yes, we have Pierre Stutzinger with us today also, conveniently coming right after a GRISP talk. But this time he's not talking to us about GRISP, apparently. He's talking to us about a debugging tool that comes with Erlang OTP, and I just learned exists after many years of using Erlang. So
yeah,
Pierre,
that was yeah. Thank you, Stavros. Yeah, happy to be here. Yeah, I was actually like thinking about a lightning talk topic for a while, and then really about 2 weeks ago, I stumbled upon something. I actually I actually misunderstood a Python feature, which I read on Twitter. And then kind of like when the misunderstanding cleared, because I thought, yeah, I want this in Erlang. And I asked about this on the Slack, and kind of like when I clarified what I actually want, then I got a message from a member of the OTP team, which pointed me to a feature that has been there since a while. I checked back until R16, and it was already there in R16. So that was not the first Erlang version I used. I think I started with R11 14 years ago, and I was not aware of this feature. So it's a debugging feature. So let's look like to have a bit of useful learning content here. Kind of like we have lots of useful debugging tools in Erlang. There's a debugger, which I kind of like shaded like slight gray because it's actually not really useful, but it's there. But if you want to debug concurrent things, then a single-stepping debugger is not useful, because once you stop one of the processes, everything else times out around you, and then you're in hell. There's logging, there's dtrace, which lets you actually inspect the Erlang VM itself and trace. There's the observer tool where you can actually inspect your system. If the Erlang system goes down, you get a crash dump. So there's crash dumps, and there's crash dump viewer, which is part of observer, and other tools. Lots of tools and techniques are talked about in this URL. So actually save this URL. That's a lot of interesting things. There's quite recently OpenTelemetry, which kind of like gives you a lot of insights in your running system, which also help you debugging things. The most important one is debug tracing. That's why I put it in the middle. So basically, should we have like newcomers to Erlang in the listening to this talk, learn about debug tracing. It's the most useful thing. It's basically the built-in debug. There's BIFs that do this, and there's libraries that actually help you. An older one, Redbug, and a newer one, Recon, from the author of this, from Fred, which gives you a nicer user interface. There is also, of course, I/O format. I kept it to the last, but you shouldn't do this. So this is like, don't do this. Don't do this for debugging. Because rather learn debug tracing before you start plastering your program with I/O formats. So what is missing here? In embedded systems, we often have a ring buffer of kind of like very low-level things where you can actually stuff a few pointers or stuff a few values in there to actually debug down to really like the interrupt level, because you can make it very simple, and it's just a kind of like an array where you cyclically store stuff, and then when your program crashes, then you can actually look at the array in the debugger to get some kind of like backtrace information about what actually got the program here where you are, which is sometimes useful. It's more than a stack trace, because the stack trace only shows you the layers of the calls into the stack, but these are actually the calls that happened, or the information that you actually decided to trace. And I basically, some hardware debuggers also have this built in. They trace the system, and they do a ring buffer. We have tracing, but tracing needs to be set up, and it's a little bit dangerous to use in production. So what did I discover? The one more debugging feature. There is a process flag, save calls, which takes a number, which actually sets the size of the ring buffer, which is actually built into OTP. And then when you can actually, at any time, you can actually use process info, either just process info, then it's part of it, or you basically can pass the thing that you actually want to know about, last calls, and then it returns a list of tuples, module functionalities, of all external function calls, so not the local ones, or the atom send, receive, or timeout for basically send messages, received messages, and timeouted. You don't see what messages, but you know that it happens. It also goes into the Erlang crash dumps, and Observer also shows it. So let me give you a short demo of this. So I need to actually stop share and share my terminal. So this is the right terminal, I think. So you see my terminal? Yeah, you see it. I see it myself. So we just start an Erlang process. So which process do we debug? The most convenient one around, the shell. So what we set is basically we call process flags. You don't need to tell which process. Save calls. And let's say we don't want a long list. The last 32 calls. Could put 1,000 here. Oh. That's the error I always make. It's actually process flag. We're setting one process flag after all. And it gives you back the old value. So it was set to 0. So now when I do process info, self, because there I need to tell it which one, about myself, last calls. Then I get this list of tuples, and we see it actually calls Erlang internal BIF, GB sets, ORD sets, is element, list member. So that's kind of like the stuff. And And I made the list too long, so let me show you the full list. So the last one is actually Erlang process info. That's the last call we did to actually get this list. So one more thing to show you. Oh, no, that was a mistake. If you have time for that. So we do process flag again, and then we do observer start. And I also ask it for self here to actually know which PID we're actually looking at. And now I need to show you yet another window, namely the observer window. I don't want to share my whole screen because it's too large, then nobody can read anything. So basically observer shows you this, and you can go to processes. And now we know that we are looking at process 79. Oops, sorry, misclicked. So we want to sort by PIDs, and it's 79. So this is the shell. So we double click it, and here we have the last calls. Last calls, send Erlang, but it doesn't show you many calls. But at least you see the last calls.
And
it's shown.
It is likely that you see some different window than we are seeing. We are stuck on the main window of the observer.
Oh, why did it do it? Oh, it opens another window. I'm sorry.
Yes, exactly. And I
I'm
was
sorry.
ready to come on the screen as you were about to double click predicting this.
Yeah. So that's the window that actually popped up, because you can look at multiple. So you see the last calls here, the entrance of this thing. So now we lost Stavros. That's thing. So I need to take over what. So yeah, that was it. Stavros, you were muted.
No, I'm not.
No, you're not. Yeah.
He was just hiding. It's a feature of Unreach. You can hide.
So actually, a question to the audience: who knew about this feature before? Brujo did, of course. Anyone else? No. Okay, so I don't feel bad about not knowing about this. But I do so know it's very useful.
It's pretty clear that you
yes, exactly.
had a lot of pain in debugging systems, and
I was tempted to start a poll about how many are actually using IO format, but I decided against it because that would get us a bit depressed, I think. Any questions? Brujo wants to come on the stage.
So yeah, Erlang tracing tools. There are many hidden secrets there. Let me show you one of them. Need to open it up in a small window first, otherwise it will be unwatchable for people with wide screens. And this is this one. Do you see my GitHub? Yeah.
We do.
Okay. So ET. And of course, you have this amazing function here. And you can do ET phone home.
It is obligatory.
It's obligatory, and it does come with ODB. It just does nothing, so you can trace. If you want to trace something, you can trace ET phone home.
Cool. We got a question for Pierre. So one can clearly use this with an RPC call to get info
Yes.
from Chris.
By whatever means. Actually, I searched the OTP code and looked where it's actually used to actually find out where you can actually get at the info. What's actually, I think, missing is if you get a stack dump, like a crash dump, then it should be actually added there too, I think, by default, if it's not empty. That would be a nice feature, and I'm actually working on a pull request already, maybe.
Great. Okay. This was the last scheduled lightning talk. I haven't received any signals about somebody wanting to come to the stage here. So I guess we can conclude the last session of the workshop and then head back to the lounge and continue discussing in one of the tables. So great. Thank you very much all for being here today and joining us in this second virtual Erlang workshop. I did not say spam, like, and subscribe, so I don't understand why it's all these things appearing on the screen, but I guess it's just Pablo. Oh, yes, the poll. Thank you very much for the reminder. It seems that there were a lot of people today here that this was the first Erlang workshop, and we hope that it will not be the last. And more answers are coming on the higher levels. I think I barely cleared the less than 5 category to belong in the less than 20. I think this one is my 6th. Yeah, thanks again to all the students and the organizers for ICFP. Thanks to everyone in the program committee who spent a lot of time reviewing papers that were submitted to the workshop.
Don't forget to submit your paper for next year's workshop. It's a great pleasure to have all these interesting ideas coming in. If you're from industry and feel unsafe about writing papers, I guess Bruno and name's Laura, are a good example of how pairing industry people with people who are experienced in writing papers, academics, for example, work well together. So don't hesitate to grab somebody and discuss your ideas now. Typically takes a little bit of time to prepare a paper. Yeah, I hope some of the lightning talks maybe turn into something that we can present in more depth than next year. And yes, with this,
I keep getting questions in the chat for the poll. Is it not visible on the stage for everybody else? I mean, who would be able to tell me? No, it's shown live. What? And no percentage.
Oh, I can see them. So it's 9 votes and 45% for first time. 10% and 2 votes for a second time.
Annette, you should share the results. Like you should probably get a button to share the results or something, because you're the creator. Or?
I can only show on stage and hide.
Oh my, this is so unfair. Okay, again. I can share my screen, but I cannot share the screen, or cannot present while the question is shown on the stage.
Yeah.
Okay, Hermit leaves things to be desired. So 9 votes, 45% first year, 2 votes, 10% second year, 5 votes, 25%, less than 5, 2 votes, 10%, less than 20, and 2 votes, 21, all of them.
My guess is this was probably John Hughes, I guess, who was around earlier, and Stavros maybe. So
me? Why? What?
Not Stavros, sorry.
Costas, probably.
Costas, sorry. Costas, of course. Yeah.
Although I don't even get that.
Yeah, it's getting late. I'm starting. Should stop doing that. So yeah, thank you very much. Hope to see you in the launch. I will be around for a couple of minutes more, and I hope to talk to some of you and see you again next year. Maybe in person. It will be in Slovenia, I think. More details will be posted on the typical channels. And yes, thanks Stavros again for co-organizing.
Thank you, Annette. This will be Annette's last year also as a co-chair. So going out with a great workshop, I think. At least I appreciate her help a lot, and the work that presented and all of it.
Same here. We'll be part of the team next year again.
Yes.
Okay. Then
thank you, everybody. See you outside in the lounge.
Yeah. Bye.